Hello, welcome to another stream. Talk about that. Talk about that. Welcome. Hello, Go on the Third, Yatanasov, Gilo, Gabiloop, Mr. Botka, Sasalola 23, Yayland 6, Atlanta Jose, Erhan Kurnas, Kolumbetka, Gabiloop, hello, welcome. Really glad to see you all today. So today is Wednesday, if I'm not mistaken. I think I'm not. And that means today, according to the schedule, we continue developing our virtual machine. Today we're doing a special thing. In our virtual machine, we have translation directives. Well, it's not really in our virtual machine. In the assembly for bytecode of our virtual machine, we have translation directives which allow you to define compile time constants and whatnot. And it would be kind of cool if you could have compile time expressions, right, that you can evaluate at compile time, and they would be used for an actual translation. So I was thinking about that for quite some time, and yesterday I actually finally came to the conclusion and a rough idea of how it could be implemented. So today we're gonna do exactly that. For example, you can define a compile time constant like n equals 30, and you can then use it to push on the stack and whatnot. So what I'm thinking is that you should be able to do something like plus 39, right? So, and if you do something like plus 39, at compile time, this entire thing will be evaluated to 69, right? So, and that's quite cool. And what would be even cooler if you could define something like const m equals 30 and use m here, so it doesn't really require to be like that. Yeah. So this is basically the idea of compile time evaluation, and maybe even further, you probably want to ditch completely like n and do m plus 39. Why not? So yeah, it would be kind of cool to do these kind of things. Maybe you're gonna have like compile time functions, right, that you apply here, and they will be evaluated and whatnot. Like predefined compile time functions. That's what I mean. Predefined compile time functions. Yeah. So yeah, like sine, for example. I don't know. Maybe you'll be able to compute sine at compile time. But to get to that level, we first need to prepare the base, right? We need to prepare the base to do all of that. Bit69 Trim, Cerimon, hello, welcome everyone. Hello. So yeah, that's the idea for today, and before we're gonna start, I need to pour a cup of hot water because I need to make a cup of tea. So yeah, just a second, it's gonna be super quick, trust me. Have I ever lied to you? No, I never lied to you, so it's gonna be super quick. You see? It was super quick. Here I am. Rock you like a hurricane. Sorry. So, yes. We'll see how we're gonna implement all of that. It's gonna be very interesting. So first, I think I'm gonna just outline the parser that can parse this kind of expressions and build AST. And once we have that working, we can add more different kinds of expressions and evaluation things. Yeah, that's gonna be roughly the idea, hopefully. So that's what I have on my mind. How everyone is doing? What do you have on your mind? Do you know resources for practical, proper Haskell error handling? I cannot understand when to use try, catch, smart constructors, either, etc. Believe it or not, same. I don't know when to use them either. So, and I don't know any particular resources to learn how to do all of that. So I would suggest you to maybe ask in one of those Haskell communities, like maybe Haskell subreddit and whatnot. But my personal approach when I have to program Haskell is that I use whatever mechanism is used by the libraries I use. Make sense? So it feels like one of those very opinionated area where different people think different kinds of mechanisms are the best way to handle things. In reality, none of them really work. so that's why people still argue about that. So essentially, and those different people create different libraries, and in their libraries, of course, they force their opinion on the users of the library. That's basically what happens, you know, usually in the library community. Right, and what I do is I just use whatever mechanism the library wants me to use. And it could be quite hard because you could be using several libraries that use different mechanisms, and you have to, you know, juggle between different error handling mechanisms. And to be fair, I haven't seen a proper solution to all of that. So I guess welcome to Haskell. It's a beautiful, beautiful language. You'll love it. Anyways, Mr. Simmer, can we please gamble again, Pepper Hands? I might have a problem. Gamble what? We don't even have anything, you know, to predict yet. So I don't even know. Alright, so let's fetch the latest changes, I suppose. Let's fetch the latest changes. In C, by the way, it's kind of quite cool, right? You don't have exceptions, you don't have error handling built into the language at all, so you basically have error no if you're working with the standard C library. You have something else if you're working with a different library. So yeah, it's great, trust me. Alright, so let me... Did I already fetch everything? I didn't see the branch. Did I already merge everything last time? Yeah. And let's go. So we're gonna go to the VM. And what do we have? Let me try to rebuild everything just in case. No build 2, no build 2C. It's actually not 2. I've been working on a rewrite of no build, which is called no build 2, so that's why I have developed like, reflexes to do this kind of stuff. I'm really sorry. That happens to me sometimes. Sometimes. Alright, so I'm gonna go to the bosom interpreter and let's just see what we can have there. Right, I'm gonna start with defining an AST. Right, so what's gonna be an AST? I think AST node is gonna be called an expression, right? So since we're defining the expression language, right, so the node is gonna be called an expression. And within the expression, we need to distinguish different kinds of expressions. So I'm gonna introduce expression kind, and expression kind is essentially gonna be an enumeration, right? So it's gonna be type def, enum. And what kind of expressions do we even have? So that's kind of interesting. Expression kind, first of all, it's probably going to be binding, right? So it's going to be binding. It's essentially when you have an expression 1 n plus 1. In this particular case, you have a tree, right? So let's actually take you have a simple tree with 1 root and 2 children. So let's actually open my paint. Our paint, okay, comrade. Right, so we have n plus 1, right, and you have this kind of tree, classical tree. So. So at the top you have operation plus, and one child is n, another one is 1. So, and you have 3 kinds of expressions here. So we have 3 kinds of expressions. So here's the first expression. Maybe I want to use a slightly different color just to be able to, you know, distinguish between these kind of things. Right. So, and this one is an operation, right? So, rather operator, I would say. It's an operator. Right, this one is a binding. Right, this one's a binding. And this one is a literal. There we go. So, yeah, you have a tree, and each node, like, it has different kinds of expression, right? This is an operator, this is a binding, this is a literal, and this is why, this is the kind of enumeration we need, all right, to indicate what kind of expression we're dealing with. We're not gonna introduce operators yet, by the way, because I don't wanna introduce new features into the language yet. I just wanna prepare the, I guess, the code for more features, right? Okay, so we have a binding, then we have expression kind literal. So right now, what other kind of literals do we even have? Maybe we should distinguish between different kind of literals. It could be like expression literal integer, and literal is too long of a name. Maybe I'm gonna just call it lit. Right, so it's gonna be lit integer, lit float. Another one could be lit hex. So this is different kinds of literals that we have. Then we have a literal character and literal string. Do we have anything else right now? I don't think we have anything else right now, so should be pretty straightforward. Yeah, that's pretty cool. All right. So then we have an expression value, right? So we probably want to do something like union, but usually people create a separate tab for this kind of union. So maybe I'm going to introduce something like expression value, right? An expression value is going to be exactly a union. By the way, what is 7 meme? I don't understand it. So try to imagine that 7 is a hand of the emote. So what kind of gesture it is? What kind of gesture looks like 7? Okay, you're welcome. Welcome to the internet. I'll be your guide. Gaylolo, what's up? What's up? What's up? Okay. So I think we're gonna create a lot of different types, just like we are programming in Ada. So type def union, I think, is gonna be our expression value. Expression value. And what kind of stuff we're gonna have here? I think we're gonna have something like maybe binding, maybe expression binding, right? And we're gonna call it as binding. So essentially the idea is the following: if you have an expression, right, you can always check the expression kind, and you can take the expression value, interpret it as a binding, depending on its kind, or maybe as integer literal, or something like that. And this is why I call these fields, you know, with that name. It's kind of similar to a word. So if you have a word, yeah, so basically it's a different kind of reinterpretation of the same value. Hello ULL star, welcome to the stream. So what we're gonna have here, we're gonna have like different types for all of these things. Expression, lit, int, and interestingly enough, what I'm gonna store there exactly. What do I plan to store there exactly? To be fair, maybe I don't need to distinguish between hex and integer. Like I don't see any point in distinguishing between hex and integer, so I'm gonna just probably only have an integer. So it's gonna be as lit integer. Then we're gonna have lit float and lit char and lit str. There we go. So, and you'll be able to actually distinguish between them. So we have a raid from Not Null Not Void with 26 raiders. Thank you so much for the raid and welcome to our language development stream. Pretty much. What were you guys doing? Were you programming in C? Or were you programming in something else? Yes, welcome. Cheers. Interesting. C like C++. I see. So for a good minute, you guys were not talking anything, and I thought that maybe it's like an actual introverted community where neither the streamer nor the viewers even say anything. And I thought, wow, that's pretty cool. An actual introverted community. Hello, everyone. Anyway, so let's actually define all of these types. So it's going to be expression binding, and the binding, I think we're going to just have a name of the binding. It's going to be string view, of course. So yeah, fake introvert. I mean, what is a fake introvert? Why do you need to fake that you are an introvert? Right? Imagine that you are an extrovert and you need to fake that you are an introvert. First of all, it's going to be super hard for you. Second of all, why? What's the point? All right. So, and this doesn't have to be a union, by the way. It has to be a struct. Export lit int, and in that case we're going to use it as uint64t. Is it going to be as uint64t? It actually depends. Well, yeah. If you need to do different kind of arithmetic operations, so in case of a plus, right, since we're doing 2's complement, it doesn't matter if it's signed or unsigned. 2's complement is going to take care of that anyway. But if we're gonna do multiplication, that could be a problem if you use only unsigned thing here. But we don't plan to have any operators right now, so the only thing I'm doing is just I'm refactoring the internals, but I'm gonna leave the behavior as it is. And as it is, we don't have any operators, so that doesn't matter. So yeah, that's basically what I'm gonna do here then. And to be fair, since all of that stuff is just one struct thinking, maybe I don't need to create all of this. By the way, so it's gonna be char, it's gonna be str. Yeah, I think right now it's a little bit overkill to do things like that, so I'm gonna just use string view. This one is gonna be just uint64t. This one is going to be double, of course, because we do everything 64 bits. And then we're going to have a char, and then here we're going to have another string view. There we go. So this is going to be expression value. Oh, what's up, Anaboth? Welcome to the stream. How are you doing? So yeah. We're implementing compile time expressions. Alrighty. So yeah, that should be it. That should be it for now. And at some point, if we're gonna introduce like an operator, it could be expression kind, maybe something like plus, and then we can introduce expression plus, right, which is a structure. That keeps a pointer to two expressions, left and right, and then we're going to have this thing here, s plus, right. But that's going to be in the future. We're not going to do that right now. So basically, this is the point of the whole refactoring. So in the future, we can do something like that. Right now, we don't really have to do that. Alright, so we have our basic structure of an expression. So the next step is probably we want to be able to parse an expression. Doing fine, someone at work decided I would be a good code reviewer. Nice, time to reject pull request with spaces. To be fair, like, in that case you could automate that, right? So essentially on CI, if you have access to CI, you could set a check if the pull request contains spaces, just automatically reject all of that. And so, yeah, you don't have to do anything. You know, automating boring parts with Python. So, yeah. Usually what I do is that I basically put a formatter on the CI, and if the pull request doesn't have a proper formatting, it's rejected, and we never discuss formatting in the pull requests ever, because it's automatically checked by CI. Alrighty, so what I want to have here is an ability to parse expressions. They say reject tabs, our formatting rule is to use 2 spaces. Ah, I see. So you need to actually hack the CI. That's what you need to do. Alright, so, oh yeah, I see. Essentially, you don't have an access to CI, but since you are a reviewer now, you can basically subvert the CI. I see your point. Nice. Parse expression. So, yeah. We're gonna accept the source. And this entire thing is gonna return the parsed expression. So, and let me see how we're gonna do all of that. Essentially, I think we're gonna start maybe with tokenization, right? With tokenization the expression, and we need to understand what kind of tokens are we going to have. Yeah, so let's go ahead and do that. It's gonna be type def enumeration expression token kind. Yeah, expression token kind. And what kind of expressions do we have? You write in a compiler? No. Alright, so right now, so we don't really need anything special, I think. We could have just a token expression, maybe just token kind symbol. Do we want to handle strings somehow? Yeah, I think we want to be able to handle strings. So it's going to be str, it's going to be char, str and char. Because tokenization should properly handle strings. Tokenization should probably handle strings and characters and stuff like that. So it has to just basically grab everything in between these things and treat it as a single token. That's quite important. Hello, WTF Bulb. Will LLVM be a target of your VM? Probably not, but maybe. If somebody implements that. I personally don't plan it. Alright. So what other kinds do we want to have? We want to have a symbol, of course. So in symbol is just gonna let's call it a name. I think we're gonna just call it a name. And then we can try to do something like token kind number, right? But it's not really a number. It's something that starts with a number, right? Well, not necessarily. Yeah, let's just call it a symbol. So we have strings, characters, and symbols. Do we need anything else? I don't think so. We'll see how it goes. So I'm gonna also define a structure called a token. Right, it's gonna be a token. It's going to have a token kind. Right, and also is going to have the value, right? So the text rather of that token, so we can grab it and maybe parse it, right? In case of if it's a string or character or something else. So yes. All right. So here's the token. Here's the expression, and maybe let's define a function called tokenize. It is going to accept the string, right? It accepts the string source, and it should return the list of tokens, right? It should return the list of tokens, but how many is it going to return them, and where is it going to put them? So probably we need some sort of like stretchy buffer yet again, but maybe not. So for now we're gonna put them in some sort of array. So it's gonna be array of tokens. So it's gonna be array of tokens, and you also have to provide the capacity of the array of tokens. Right, and then you'll have to will return the amount of the tokens that we successfully parsed. the amount of tokens that we successfully parsed, or maybe we can even introduce a type called tokens, so it's easier for us to push things into the tokens thingy. So it's going to be type def struct tokens, and so there is a single token and there is like a tokens here. So there are internal tokens, single token, tokens capacity, and then we're gonna have amount of tokens in there. We're gonna have the amount of tokens, and then I can just, you know, accept tokens like this. So you're gonna provide the pointer to the tokens, and we're gonna push those tokens in there. So the capacity is gonna be some arbitrary value, right? So let's actually define something like, I don't know, tokens capacity 124. I think this should be enough for now. We're just testing things around. All right. So what do we got? Let's try to parse all of this. Before we parse all of this, I think I want to prepare the a place where we're gonna actually test everything. So I'm gonna define tokens, and let's just parse something. Let's just try to parse something. Right now, all of our expressions, they have a single token anyway, so it doesn't really matter that much. But I mean, we can do the following thing. So we're gonna do tokenize, tokenize. So right now we have what kind of tokens? We have symbols, like this. Then we have strings, right? And it's quite important for a string to actually include this hello. And also another token that we have is a character, right? So we need to be able to tokenize this kind of thing. Hello people, I haven't written C++ since uni, but I'm about to get back into it for some scientific project. Can you point me to some good learning resources? I'm a Go, Python, JS guy. Good learning resources in C++? I don't know. To be fair, the only thing I could probably recommend is the Strausstrup book, but I don't know if you need to quickly get up to speed. So you already know a little bit of C++, so it should be easy for you to, you know, recover your knowledge. I don't know. Maybe somebody in the chat can help you, but I don't really know any good resources on C++. The way I program in C++ is just I want to do something, I Google thing, and I just do the thing and then forget about it. So seriously. My approach to any language is just essentially copy-paste code from Stack Overflow, so I'm not a really good person to ask this kind of question, I'm sorry. But maybe book. Book is too much, like it depends on how much time do you have, right? So book is pretty thick, and also Strausstrup have written many books on C++, so... Alright, so let's actually iterate through all of the tokens that we have here. So it's going to be tokens, count, plus I. Oh, I have an idea. So maybe I'm going to implement like printers for a token. Probably not. So, so we're going to put it like this. So this is going to be S. And it's going to be token kind as sister, right? Token kind as sister. So tokens. Tokens. Yeah, this is a very bad choice of a naming, in my opinion, because yeah, you usually have something like tokens, right? And then you want to access the internal elements. And when you access them as doing tokens, so calling them like tokens is not particularly a great idea in my opinion. So I think I'm gonna call them something like elements, right? Elements. So we have tokens, and you take the elements of this token structure. So I think it's gonna be a little bit better, just a little bit, not necessarily absolutely perfect, but we'll see. So we have an elements I, and you want to take a look at the kind of that element, right? You've got the kind, and then you probably also want to print the string that represents all of that. So we're going to do it like this. So I'm going to take it as S, but I know that the string is string view, so that means I can do something like this. I can do SV format, right? So, and now I should be able to do SV argument, on token element. On token element text, there we go, and that should print everything. So it will print all of the tokens in here. All right. So, and maybe at the end we want to put an end to indicate that this is where tokens end, just in case the we didn't parse any tokens and this entire structure is empty. Also, you want to zero initialize it as well. Hello, Luke Wexler. Welcome to the stream. I'm doing great, I suppose. Like just programming in C, nothing particularly special. So no previous prototype, so this means that this thing has to be static. So we have unused variables. So let me quickly try to use them, right? So, but all of that is warnings. So where are the errors? We have an errors. And what's the, oh yeah, I know what's the error. So this is a string const char, right? So it's a C string. But what I expect here is a string view. So I need to do sv from sister, and that will convert the sister to the string view. There we go. Will it work? It still doesn't work, and it has a lot of warnings that I don't really care about. So what's wrong in here? Undefined reference tokens as, oh yeah, so I'm referring to a function that doesn't exist yet, right? So it's called top-down development, right? It's okay to refer functions that are not yet developed. It's totally okay. It's not insanity, trust me. So it's called top-down development. That's what it's called. So then you have a kind, and then you want to do switch on that kind, right? You switch on that kind, and then you grab all of these tokens in here and just put them here, and then you do a little bit of Emacs magic. Then you replace all of these things with these things. There we go. And then maybe you want to use this kind of stuff, and then just boom, 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 Emacs magic. Can your Vim do that? I don't think so. Haha. So also I want to do assert unreachable, right? Unreachable. Copy paste an answer from Discord for beginners. Learn CPP. Oh, that's actually pretty cool. So we have already learned Rust, right? So let's actually create a command for learn CPP. Learn CPP. Okay. All right. That's a pretty cool compilation of things. I have no idea if they're good or not, but since Kolumbetka recommend them, I trust Kolumbetka, so let's actually add a command for that. Thank you so much. Alright, it's pretty cool. Actually, educational community, how about that? Isn't that amazing? Amazing, absolutely fucking amazing, mate. Alright, so does it compile? So yeah, I forgot this. I forgot the colon, right? I forgot the colon. So let's actually put it here, and yeah, it's compiling everything. Beautiful, absolutely beautiful. So I also want to try to run this entire thing. It's going to be build Bosom. Am I actually running it in the correct place? I don't think so. Yeah, so this is what I want to do here. It's going to be build bin Bosom, right? And let's see how it tokenizes things. As you can see, it just printed end. That means it didn't tokenize anything at all. So, which is expected because we haven't implemented the tokenize function yet. Right, so that's pretty cool. Yeah, let's do some tokenization. Let's do some tokenization. So we're gonna keep tokenizing things as long as source is not empty. So we're gonna do that by checking if the count greater than 0. So that's pretty cool. And the first thing we want to do, we want to trim the source, right? So it's going to be sv trim trim left like this, and that will remove all of the white spaces from the beginning of the string view. And then we can start checking for different kinds of the characters in there. Right, so it's actually quite important, if you ask me, because at this point, after removing all of the spaces, the string can become empty, and that means we need to check this condition yet again. What if we trim spaces right here so we don't have to check it here. And then we need to add this trimming one more time. So basically, instead of checking this condition twice, we can only check it once, because we guarantee that before checking that condition, we always trim the source. I think it's a little bit better. And then we can switch upon the first character. We know for sure that we do have the first character. This is actually kind of cool. And the characters we're looking for double quote. That means we need to parse the string. Token is string. Then if this thing is single quote, token is char. And if it's something else, we're going to treat it as a symbol, right? We're going to treat it as a symbol. Token is symbol. Right now we only have 3 kinds of tokens, right? Only 3 kinds of tokens, nothing special. All right. Music is finished already? That's pretty sad. That's very sad game. Anyway. So essentially, if this thing is that, we need to find the next double quote. That's what we need to do. We need to find the next double quote. But furthermore, we also have to like chop a single character out of the source. So the easiest way to do that is actually to increment the data and decrement the count. Right, but maybe this should be turned into like a SV function. Something like SV chop, and you provide the source, and you can also provide the amount of character you want to chop from the left side. Right. Or maybe it could be something like slice, SV slice, yeah. So maybe chop is gonna be better. And also it could take, it could also handle situations when your number is too high. So in that case, if it overflows the size of the whole string, it can just return you an empty string instead. Something like that. Do I want to introduce that? I think it's a pretty useful function, so I think I'm gonna straight up introduce it. So let's implement SV chop left. So it accepts, it might as well actually act similarly here. So it might create a new string view to be more like pure and whatnot. Right, and how many things we're chopping here? So it's going to be something like n. And first thing we want to check, if n is greater than the size of the whole string, well, then set the n to the size of that string. So it will make it a little bit more safe, right? Then we're just returning a new string view. So we're chopping things from the left. So that means the data is going to be equal to data plus n. And the count is going to be equal to the count minus n. There we go. So that's basically what we have here as we chop left. And we can remove this entire thing. So that removes this entire character here. That removes the entire character here. So now we need to find the next quote. We need to find the next quote. So how we're gonna do that? So we're probably gonna do something like this, right? For I equals 0, while I is less than source count plus I, and so it probably makes sense to make it while. I think while is going to be a little bit better for this particular situation. So this one is going to be like this. This and source data I is not equal this thing. We just keep incrementing this entire stuff. After that, you have two situations. You have either this being true or this being true, right? So if this is true, you found the end of your string. So what we need to check here, we need to check if this thing is true. If this thing is true, what you want to do? If this thing is true, that means you found the end, and you just need to chop. Well, chopping actually removes like everything. Like you could have just, you know, sv chop left source I and just use it as that, but you cannot easily do that. Unless your function is like this, you accept a pointer, so that means it modifies this value and then it returns the part that was chopped off. I think that is better. Since there is an end in the while condition, both are true, right? No. Since there is an end, the condition will continue as long as both of them are true. So now, so the thing we're gonna do here, data plus n. Just because you put and there, it doesn't make them both true. It means something else. All right. So we also have to prepare the results ahead of time. You have to prepare the result ahead of time. Data is going to be sv data, and the size is going to be actually count equal to n. Then you just set it like this. There we go. So that is a more general function, and for example, it allows you to ignore the result. For example, in here, I just want to chop off this double quote, but I don't care about the double quote itself. In that case, I can just do something like that. Cool. But in this case, I do care about the result in here, right? So, and that's why I just do like this, and that thing should give me the value of the string itself, right? So let's call it str. So, and that also automatically modifies the source and whatnot. And also after that, I want to chop off that single quote character that we had in there. And there you go. So I have a string. The only thing is left is to add that string to the tokens array. Right. So it's going to be tokens. Maybe I'm gonna just do something like push. I push it to the tokens, and let's create a new token here. So it's going to be token. The kind of the token is going to be token kind str, and the text of the token is going to be the str. There we go. So we managed to parse this entire thing. And if, for example, this thing became greater or equal to the source count, that means we didn't find the closing quote. Right, we didn't find the closing quote, and that means we need to report an error. All right. Okay. So, and to report an error, this one is going to be very interesting, right? Because we can try to return a position relative to the expression. The position relative to the expression, at least. And what's the easiest way to do that? Well, let me see. So maybe we're gonna introduce some sort of a type for reporting tokenization errors. Tokenize result, right? Tokenize result. So what it's gonna store is basically whether an error has happened, right? So we're just checking is an error has happened. Another thing, it could be where exactly the error has happened, right? Where, and it could be some like position within the string, just a character position within the string. Do we need anything else? Maybe some sort of an explanation could be. Yeah, could be something like string view. Reason. So if tokenization went well, to be fair, right now we can just crash, but Yeah, let's just crash, because I will spend too much time trying to think how to recover from the errors, and instead of writing an actual tokenization. Okay, could not find closing this thing. And it's going to be written into std error, right? And then I'm going to just do exit 1. There we go. So we managed to parse we managed to parse the double quote. Just the double quote. That was pretty straightforward. All right. So so if I got the break here, sip some tea, nice. Tea is nice actually. Yeah, I still have a little bit of tea left here. No support for escaping inside characters. Yeah. The code isn't finished. Zozin, why your code is not finished? Jesus fucking Christ, people. Holy shit, you're literally trolling me right now. Okay. So yeah, so in case of the prime, right? In case of a prime, we want to do pretty much the same thing, right? We want to do pretty much the same thing, but find the character. So I'm gonna just copy paste it here. I'm gonna just copy paste it here and just replace this thing like that. So it's pretty much the same thing if you think about it, like, right? So it's pretty much the same thing. Could not find enclosing, but the only difference here is going to be that this is a character, right? This is a character, and that one is a string. So maybe we can think about, you know, extracting some of the stuff into separate functions. All right. So maybe something like find char, right? So, or maybe sv index of, right? Sv index of is going to be a string view, sv. And you provide a character here, C. So, but also it can fail, if you think about it, right? It can fail, so we have to return it as an integer. Or maybe we can return it as size, right? But size is not portable, so we have to use an integer, right? It's always fun. But to be fair, you know, you can always return the index, you know, the result as boolean, right? Index of, and the index is going to be here, right? It's going to be via the pointer. So, and that may enable pretty interesting things. It may enable pretty interesting things. So let's actually quickly do that. Size t I, while I is less than source count, and source data I not equal C. Not equal C, and yeah, so we just keep incrementing this entire thing, right? If I less than source count, that means we can just return an index and just return true, right? Otherwise, we just return false. So, and with this kind of function, we can, oh my god, where's going on? We can essentially get rid of this loop, only leave the index, right? We only leave the index, and we just do sv. What was it called? Index of, right? It was index of. Sv index of. Then I provide this source in here, the source, the character that I'm trying to find. Right, the character that I'm trying to find, and pointer to the index. And then within this entire thing, I'm just reusing the index like this. So that enabled me with removing this entire loop from here, and probably I'm gonna remove it from there as well. So should be pretty straightforward. So I'm gonna put it here. So, and also we want to have something like size t index in here, size t index, and here is the index. Okay, so it probably could be it probably could be also possible to squash it even more, but I don't really want to do that right now, so I think it's too much. I think it's too much. Alright, so now let's try to do the symbol parsing. We don't need to break if it's a default branch. I think I'm running out of tea. So I'll probably have to make another cup soon. So, do I have a function that chops a word? So we can chop by delimiter, but I don't remember. Oh yeah, it returns you the whole thing, so we can reuse this function. So we can chop by delimiter, so we're gonna provide the source code, and the delimiter is gonna be this space. Right, this delimiter is gonna be the space. And the symbol, right, string view. Okay, that's totally fine. This one is going to be value. And what we need to do here, we just need to push this entire stuff into here. Symbol, value. Okay, I also kind of want to rename this thing to value, so I don't confuse them. So I don't have to come up with the name for them, right? Because if I just call it str, that means I need to call this one char, and char is the name of the type, and that means I have to use C, and let's just not do that. Let's just call it a value, right? Or maybe since the member here is called text, I might as well actually call it text as well. I think that's even better idea. Look at that. That's even better. Yeah. Bike shedding. Let the bike shedding flow through your veins. That's exactly what I want. Cool. So we implemented the tokenization for our language, I think, and let's take a look at the main. Right, so we have a bunch of tokens in here, and we have only symbols, strings, and characters. So let's see how it's gonna go. It does not even compile. Nice. So prototype, this one has to be static. Sure, I'm okay with that. Static, sure, I'm okay with that. This thing needs to be like this because it's a pointer, of course. In C, if it's a pointer, you have to dereference it. It's really a stupid step, but it is what it is. It's a mistake that was made 50 years ago, and we're still paying for it. Thank you, Richie. Very cool. So I think this has to be renamed to SV. And Thompson, of course. They made this mistake together. Tokens push. So don't I have tokens push? Oh yes, I don't. Okay, so let's implement a function that pushes a token into the array of tokens. Let's fucking do that. Alright. So it's gonna be tokens, tokens, and accepts the token. Alrighty. And we need to check if assert tokens count is less than tokens capacity. In that case, I can do tokens lemps tokens count + equal token. Cool. Will it compile now? Still does not compile. Well, I mean, it kind of compiles, but with you know, no previous prototype. Yeah. But there we go. We managed to parse all of this shit. Look at that. So the original source code, well, the source that we're trying to parse looked like what? Let me find it. Here it is. So it had hello 1 2 3 4, then the string with a space in it, and then the character. So you see, it parsed everything correctly. So these three things are symbol. This is a string, and it gives us the whole string, including spaces and shit. So that's quite important. And then we have a character, and we actually distinguish between these kind of like tokens. So tokenization works, right? Tokenization works. Beautiful. That's pretty neat, yes. All right. We have a simple tokenization. How would you discriminate the pointer versus pointed operations without dereferencing? I'm not talking about pointed. I'm talking about the syntax of the structure. I'm not even talking about like semantics. It's a purely syntax of the structure. All right. So let's continue. So parse an expression. So I think I'm gonna accept tokens. Right, I'm gonna accept tokens in here. It's gonna be pointer. I don't need to modify the tokens. An interesting thing here is that I want to be able to allocate those tokens in some sort of arena. So I'm gonna actually accept the arena here. Yeah, there we go. Cool. In terms of parsing an expression, oh shit, I think I have a pretty cool idea. So I might actually just consume the tokens, right? So that means this thing has to be modifiable. But how can you consume the tokens inside of this structure? How can you make them consumable? Well, only if you had something like tokens view. I think that would be kind of cool, I think. Right, tokens view, where instead of like a very specific thing in here, like an actual array in here, you would have like a pointer, and it's similar to string view. Right, and so I can actually, you know, manipulate this kind of thing. That would be cool, I think. I like that. So, and this kind of token becomes consumable. And also, you might as well actually just mark this as const, so it's not modifiable. So, yeah. I'm not sure how good of an idea that is, but we'll see how it goes. Might as well even introduce a special operation that accepts the tokens and returns you, you know, the token view on that thing, right? So it's going to be something like tokens view, tokens as view. So we're going to accept const tokens pointer, right? And what you want to return? You want to return tokens view, right? And you're going to have elements and tokens elements, right? And then count is going to be tokens count. Cool. Yeah, unfortunately it's kind of difficult to abstract away these kind of structures, right? Because we don't have a templates in C and all sorts of good stuff, but it is what it is, chat, and it isn't what it isn't. But Zozin, why are you just not using X thing? Why are you just not using that? Just use that, it's a solved problem, Zozin. Okay, let's continue. So tokens as view, right? And yeah, so essentially the parse expression, right? Parse expression is gonna accept not the tokens really, but rather the tokens view, and it will modify it and just move forward, and so on, and so forth. So that's pretty cool. Yes. All right. So, do we need to trim anything? We don't even need to trim anything because the trimmage was already made by the tokenization phase, so we don't even have to worry about that, right? So while tokens count is greater than 0, while it's greater than 0, we're just trying to parse all that. So we're going to do switch tokens elements. So this is the first in the element. Okay, so I'm going to actually do it like this: elements. And I want to take a look at the kind of the token. And what kind of the tokens do we have? We have token kind, where it is, here it is. And I'm going to just put everything in there. There we go. That was a kind of a mistake. Okay. Alright, so this is what we have here. break. So if it's a string, alright, so I need to turn this into expression string. Yeah, pretty pogue. Pretty pogue. How are we gonna approach that? Just thinking. So I think parse expression should actually return a pointer, right? Is it not? I think it should return a pointer because you like create a structure on in the inside of the arena, right? You create a structure inside of the arena and then you just use it there. The music is going crazy, to be fair, but yeah. What else? What else do we have? Token kind str. So let's do arena alloc. Let's do arena alloc. And how many things we wanna allocate? I wanna allocate size of I guess expression. Maybe the whole expression. Let's actually allocate the whole expression. So and this is gonna be the result. Right, this is gonna be the result. And maybe I want to also zero initialize the result. But Zozin, why don't you use a map? Why don't you use calloc? Zozin, you're doing everything wrong. Oh my god, stop, Zozin. Oh my god, sure. I'm doing everything wrong. Calm down. Okay, so here's what we have here, right? And now I know the kind of the expression thing. Yeah, I saw that link, thank you so much. Kind, expert kind. Just some people cannot come down, seriously. Alright. So this is a string and the result as lit str. Maybe I don't have to call it lit. Yeah, it's better to call it lit. I think it's better to call it lit. And then I take the tokens elements text. Alright, so cool. And then we can just, I guess, return this entire thing. But yeah, returning this entire stuff will require chopping off some stuff. Infinito. I'm sorry. Infinito. Thank you so much for 2 months of Twitch Prime subscription. Thank you. And welcome to our epic parsing club. How about that? Isn't that amazing? I think it's goddamn amazing. So we're parsing things around. Yes. The 2-time champion of the channel. Finally. So arena alloc. Size of expression. Cool. I might as well actually copy-paste majority of this stuff. Oh no, Sonny, why are you copy-pasting? Oh my god, just extract it to a function. What are you doing? You're doing everything wrong. Right? Okay. So, here's a char. Looks cool. So in symbol is gonna be actually the most difficult one, I think, because you need voice of chat. Well, yeah, it's like I know exactly what people gonna say just like every time I do something because I heard that so many goddamn fucking times. I know exactly what people gonna say. I think the time has come to make a cup of tea. I kind of regret not eating right before the stream. To be fair, I don't want to go anywhere. Let's continue. Arena a lock. So we're gonna pre-allocate this entire thing. Yeah, let me copy paste it. So, and depending on what it is, actually, we're gonna just try to treat it differently. So maybe I'm gonna go to bm.h, and in the translate literal, actually, we have a pretty good code that distinguishes between different literals and whatnot, and I might as well actually steal it for the parsing, right? So we can try to do this kind of stuff at the parsing stage. Just adapt this piece of code to the parsing stage. Okay, so SV has a prefix, so what exactly are we doing there? What is SV? SV, I think, is the value, it's the text of the token. SV of the token. So do I want to extract this stuff somehow? Probably not. Another thing I wanted to do, actually, I was in the middle of actually implementing something before the sub, and yeah, I forgot about it. Tokens as view. So let's introduce something like. Yeah, I literally need the following thing. This is so fucking bad. Oh my god. Welcome to C, I suppose. Right. Tokens view. SVTV. Alright, so yeah, welcome. So, and this data is actually called elements. Okay, so we can do chop left and parse expression, right? So parse expression TV chop left, right? TV chop left, and I'm gonna just do tokens 1, right? I'm chopping left, and I'm instantly gonna return the result, right? So there we go. So I'm also doing that, and perfect. So, and in here, what I'm dealing with is tokens element text, right? Tokens element text. So I look into the text. If it starts with that, I'm just taking the arena. Probably, yeah, I probably want to extract kind and text into separate function. I think that will be super useful. String view text. So let's actually like copy paste it, because I think it's going to be too much referring to this value all the time. So you want to refer to a shorter name, right? So this is going to be that. This is going to be that. So then you're converting it to sister, right? Then you're parsing that into a result. And this one is very interesting, right? So this one is very interesting. So a result, we already have a result here, right? We already have a result here, and that's why we don't need it here. So we're gonna do not really a result, but expression value as lit int. Yes. Yes, as the lit int. Perfect. This is exactly what I want to do. If something like this has happened, we'll have to return an error. Imagine like calling lambdas zoomer technology when the paper on Turing machine and lambda calculus were released literally at the same year. Holy shit. Anyway, so whatever. I need to go and make a cup of tea. So let's take a look. So we're converting this to sister, and then I converting it to that, right? And yeah, I wanted to have a printf. Yeah, could not find closing. To do, yeah, it's gonna be to do proper error reporting. So I'm gonna actually put it like this, proper error reporting. So this is gonna be proper error reporting. So then we're gonna say svfmt is not hex literal. So it's gonna be svarg. And what exactly we're doing, so this is text, this is not a proper, is not a hex literal. So we don't have to do a result here, but one of the things we want to do here is probably put this thing here. Right, so then we chop this entire stuff, and then we return the result. We will manage to successfully parse this entire thing. Okay, so some of this stuff I think could be extracted to like here, right? So you don't have to do that anymore, right? So, so this result is that. Then we take a look at the value as also as lit int, but you use 10 here, right? You use 10 here. And if it couldn't work, you have to try fixing it, like parsing it as a float. This one is interesting, right? So this one is kind of interesting. This one has a value as lit float, right? As a lit float. So in this particular case, I may wanna, yeah, just do this thing like that as well. Oh, I know, and I also need to set everything appropriately, so yeah. So this is gonna be that, this is gonna be that, and there we go. So literal invalid, and in this case I want to actually report an error. All right, oh my god, I want to report Emacs. What the fuck are you doing, Emacs? Please stop. It didn't even copy paste everything properly. So now I'm gonna put this thing. It's not a hex literal, is not a number literal, I suppose. This could be like this. And cool, so here is that. But what's interesting is also I forgot to set the kind of this thing, right? So in this case, this one has to be something like this. You set the char to integer, right? And then so if you manage to successfully parse this thing, this is an integer as well, so you want to put it like that. But in this case, you want to do a float, right? You want to do a float. So that's essentially how we're gonna parse the expressions, hopefully. So does it return anything? It doesn't return. It should, yeah, it does return this thing. And in this particular case, it's kind of weird. Oh yeah. So since we're parsing a single thing, a single expression, not all of the expressions, right? We don't have to do that in this case, right? But one of the things we can do. Is take a look at the tokens count here, right, and if it's equal to 0, we want to say that we couldn't parse empty tokens. Alright, so I need to pour a cup of tea. Okay, so what do we got? What do we get? I kind of want to listen to lo-fi. What's up, voiceless Velar Fricative? I hope I pronounced your nickname correctly. Hello, hello. So what do we got here? Is it gonna compile? Maybe not. So let's actually do proper reporting in here. Cannot parse empty tokens. So I'm gonna push it like that. Did I forget to actually provide a... No, it's actually like this, and here's the tokens, and I also want to check for the default, so we're gonna say unreachable, and we're gonna exit with 1. There we go. So push tokens, it has to be static because it doesn't have a previous prototype. There we go. So this is called SV, so let's call it TV. Something weird in here, but okay, sure, but this is just the warnings. Oh my god, too many useless warnings, but that's okay. Static. So yeah, it has to be dereferenced. Because otherwise, how do you distinguish dereference and not dereferencing? Am I right? It's literally impossible. It's an unsolved problem of computer science. So, okay, this one is has to be a value. Okay. Incompatible type character. Oh yeah, so yeah, this one is interesting. Okay. So I have to be a little bit more careful in that particular case. So essentially, if text count is greater than 1, alright, so, and I'm gonna put it like this. The length of char has to be exactly 1. So we also can also print. We're not gonna print anything right now. But what about escaped characters, Zozin? What about escaped characters? Do you support escaped characters? Did you know that escaped characters can be more than 1 character? When are you gonna support that? What are you doing, Zozin? You're doing everything correctly. Alright, so, and in here, since we checked everything, I'm gonna take the data. Right, it's gonna be 0. Right, so I don't have to take a point in here, right? So this one is a text. Text. Another text. Okay, so we have this thing that is unused, right? Well, yeah, whatever. Defined but not used. Token defined but not used. Okay, cool, finally. I think I finally fixed all of the errors. Cool, so now we can tokenize everything. Now we can try to tokenize everything and we can try to parse things. Oh, alright, so this one is interesting. So in case of you cannot parse things as a number, if you cannot parse things as a number, you should try to parse it as a symbol. Yeah, in this particular case, we're gonna treat this thing as a symbol. Right, so that's gonna be the easiest way to do that. So result, kind, expression, kind, binding. Yeah, this is how we're gonna treat that then. So, and in that case, it's gonna be just a result value as binding, and we're just gonna assign the text to it. So this is gonna be just a text. All right, and we don't even need to. Yeah, we can just do a result. Which also means that since we don't fail anywhere here, we might as well actually just have one single result in here. Right, specifically for this branch. But Zozin, you can extract result from other branches here as well. Yes, yes, I can. Okay. Alright. So the thing I'm thinking. So I want to iterate through all of the tokens and just parse them appropriately. And I also would like to simplify this thing. I wonder how can I simplify it? Not sure how, but maybe it will be possible. Excuse me. I also need to allocate the arena. So let's put the arena here. Parse expression. Fresh tea, yes indeed. A fresh tea. So we also provide the tokens. Cool. And now I want to just print some of these things. Expression kind, expert kind as sister, right? So, and let's see what kind of expressions we managed to parse in there. And define, yeah, so that makes sense. So let me find expression kind. Expression kind. So const char and it's gonna be expression kind, switch kind. I also need to, oh, I have to implement it one, again from scratch. So assert false. Expert kind as sister, unreachable. So we're gonna compile. There's too many warnings, to be fair. I really don't like that. It just makes it a little bit noisy for me. Incompatible pointer. Oh yeah, because this thing has to be like a... Okay, tokens view, I see. It's tokens view. TV. Tokens as view. I take it tokens. By the way, tokens as view should probably return... Yeah, it returns the appropriate type. Nice, nice, nice. So I can then do TV, then TV, and then everything is okay. So I still cannot do this thing. Yeah, because it has to be just a printf. Please recompile. Just recompile. Thank you very much. Tokens as syntax is defined but never used. But yeah, I don't use it anymore. That's fair enough. Okay, so it never actually worked properly. Nice. So it did a binding thing. But now parse expression. So we do chop left. Yeah, what's funny is that, yeah, okay, so that's cool. Nice, that's pretty cool. I like that. Okay. Oh shit, okay, so it actually printed it too many times, I see. Alright, so at least it managed to parse. So first one was binding. So if you take a look at the expression we're parsing in here, right, if you take a look at it, if I can find it, of course, I'm sure if I can find it. So first one is a binding, the second one is an integer, string, character. So we parsed all of the expressions here. Beautiful. So yeah, so we now have a notion of like these expressions and whatnot. And yeah, I'm just actually thinking, do I want to integrate like tokenization into the parsing expression? I think I do want to do that. I think I do want to do that because it's gonna just make everything easier. Right, because instead of just doing something like parse expert, but what if you have several expressions, right? So what if you have a several expression? No, you usually, in our case, we're usually gonna parse only one expression, exactly one expression, probably. Yeah, you can always have several of these, so we can do something like a parse expression from tokens, right? And then you can implement something like parse expression from SV, right? So you can always do something like that, right? And that thing will call to the tokenization and so on and so forth. But it's gonna parse only one expression. If you want to parse a sequence of expressions, you will have to like take control over the tokenization step as well, and call parse expression from tokens directly. I think it kind of makes sense. Alright, so, and yeah, of course, this thing is going to be just a string view. It's just a string view, and it's going to return expr like this. And what we're doing here, we're allocating tokens on this stack, right? We're allocating tokens on the stack. Might as well actually take the code from here, right? Take the code from here. Right. Tokens 0. So then we tokenize. So this is going to be the source. Right, it's going to be the source. Right. So then I can try to parse expression from tokens, right, providing the arena and the pointer to the token view, and that will return me the single thing in here, right? So now I should be able to take this stuff and put it here, right, and I don't have to worry about anything, because usually so what's the use case? What's the actual use case? You're gonna have instruction here, right, that accepts an operand, and an operand is going to be a single expression. So once you've got a line, you figure out where the instruction starts and where the expression starts. You just take this thing as a single expression and parse it as a single expression, and you just use it. So yeah, that's why I only need to parse like a single expression here. All right, everything kind of makes sense. I'm really happy with it. So I want to try to now integrate all of that into the virtual machine, into the assembly thingy. And in assembly, deferred. So we have different operand, we have bindings, right? We have different bindings and they have different values. Right, they have different values, and right now, yeah, this one is going to be interesting, but yeah. We want to be able to introduce something like not really a deferred operand, but rather a deferred, well, yeah, deferred operand expression, and it's going to contain, so right now it contains a name, right, it contains a name, an instruction address, but I think it's gonna contain also an expression that needs to be evaluated, right, the expression that needs to be evaluated, and what? And whether it was evaluated or not, right? So something like Boolean, expression evaluated, and then it could contain like the value of the expression, and value is in majority of the cases it's going to be just a word like expression value, right? You can always check whether it was already evaluated, and yeah, I think we will be able to integrate all of that into the virtual machine itself. I think it's gonna be great. All right, so that's pretty cool. I want to make a small break. I want to pee. So I wanna remove some of the stuff. DAC, I don't know what is a DAC, I'm sorry. I don't use anything, I just plug it directly into my laptop. Okay, so parse is not defined. Okay. Oh, this is because I'm trying to run it. Okay, I see. So let's just put it like this. Okay, so I'm gonna go to here. Alright, so this one is gonna be kind of difficult. We'll see how it goes. So this is a bosom. Alright, well, I'm gonna start with moving tokenization. Tokens push, tokens view, token view as that. Rutifand, thank you so much for 8 months. 8 months. That's a pretty long period of time of tier 1 subscription. Thank you, and welcome to our virtual machine club. That's right. Welcome. Really appreciate it. Alright, so I'm gonna move some of this stuff here. So now we have the tokenization stuff in the virtual machine itself. So maybe at some point I have to start splitting things around because it's getting kind of big. Not gonna lie, I don't think I will be able to keep this entire stuff really small. So I think at some point I'll have to start splitting things up, that's for sure. And also the function implementations, they shouldn't be here. They should be somewhere else. So I have to move them somewhere down below. So we have a token push. So let's remove it from here. Then we have a token as view. I'm gonna put it here. Tokens as view, right? So tokens as view. So that means this thing is gonna be like this. And then we're also gonna have to TV chop left. There we go. Yeah. To chop left, and there we go. There we go. Right. So let's see if it still compiles. Hopefully. Expression defined but not used. Can I somehow suppress this warning because it kind of annoys me. It just creates too much clutter. Maybe I'm not gonna use that one anymore. I think that one is totally fine to not use. So I'm okay with this amount of clutter now. Okay, so we have now tokens moved to the corresponding places. So we have a string view operations that I want to also move inside of the library. So let me see how we can do that. So we have a bunch of places like SV, trim left, trim right, chop by delimiter and whatnot. So this is where exactly we can move these functions, hopefully. It's gonna be like this. So this is a chop left, and another one is gonna be index of cool. So, and I want to find a chop by delimiter place, so I'm gonna move my implementations there. Hopefully, we'll see if I will be able to do that. Well, I mean, it's just, you know, moving like a bunch of text from one file to another file. But who knows what's gonna happen while you're doing that, right? Who knows what's gonna happen? Alright, so that's pretty cool. So a lot of stuff is moved to the library. And let's try to recompile this entire stuff. Okay, seems good. So bm.h tokens. So we can do token push. And the most important thing in here, I would say, is an ability to tokenize stuff, right? So we can take the source and the tokens, and you just can tokenize the source. Turn it into a sequence of tokens. Let's see. How can we do that? So tokens push. So we're gonna put it here. So let's quickly do that. Token push, a boom. Cool. So I think we moved to the entire tokenization. No, we didn't. Would you look at that? I forgot the semicolon. Sure, let's put the semicolon here, and everything seems to be okay. Cool. So here is the tokenization. So the next thing is parsing. The next thing is going to be the parsing. And this one is going to be interesting. Excuse me. Alright, so here are the types that we're gonna use for this kind of stuff. Alright, so here's that. So I might as well actually remove that. It's not needed here anymore. So, and the function that we're gonna use here is gonna be just parse expression from tokens. Where are we gonna place that? I think I wanna place it below TV chop left, somewhere here. It's actually right the bottom of the file. Perfect. So I'm gonna put everything here, and here it is. It's not gonna be static anymore. And let's just go ahead and do that. Everything seems to be compiling. Perfect. So do we need anything else? So this function could be kind of useful, but not for now, not for now. Okay, I think I moved everything parsing related inside of the BM file, which is perfect, I think. Which is kind of perfect. Yes, 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 nice. I want to go and run the tests. I'm going to just go ahead and run the tests. All right. So that looks very cool. Now, so when I have a binding, right, so right now bindings, they store the values and whatnot. Estimations, thank you. I hope I pronounced your name correctly. Thank you for the raid. Welcome, 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 raiders. So, yeah. We're developing a virtual machine, actually, believe it or not. So you can find the source code of this thing here. So the idea is that you have a simple virtual machine, stack-based, and it also has its own bytecode. But on top of that, we're also developing an assembly for that specific bytecode. So, and it looks like this. This is not how it looks like, I'm sorry. Yeah, there we go. So this is how it looks like. This is the custom assembly for our custom virtual machine. And here are the instructions. So it also has translation directives. They're not preprocessor, by the way. They are basically interpreted at the time of the translation, and they do have an access to the whole translation context, right? So yeah, for example, you can define a constant here, and then you can use that constant to push on the stack, and then you can start translation of another file, and so on and so forth. You can call other functions and whatnot. Yeah, that's pretty cool. And the thing we're developing right now, we're developing compile time expressions, but we don't really have a compilation phase. So translation time, right? Translation time expressions. So essentially, I want to be able to define a constant equal to 30, right? And just add like 1 to it, like this, right? And obviously, like there's no. This is not how like the assembly works. If you want to add something in this particular assembly, you have to push a value onto the stack and push another one onto the stack and sum them up. Depending on how you want to sum them up, you want to sum them up as an integer, or you can sum them up as a float. So there are separate instructions for that. Right, but this is not how it works. So this expression has to be evaluated at compile time. Right, so we're gonna have like pretty simple infix style operations that can be computed at compile time, and they will be embedded into the final binary code. So, and that's exactly what I'm working on right now. So I implemented first tokenization for the expressions, then I implemented a parser that produces AST, and then I'll implement an interpreter that traverses that AST and computes these expressions, and so on and so forth. You have a value of n at translation time. Yeah, I do have a value of n translation time. Furthermore, I want to do things like this, where I could define it like 30 and at 40, so you can have bindings that depend on other bindings, and all of that has to be computed at compile time. It has to be interpreted at translation time, rather, and all of that can be reused then to produce instructions for the virtual machine. So that's exactly what I'm working on right now. Yeah, it's kind of interesting actually. So there's a lot of interesting features in this assembly. Like the architecture of the virtual machine consists of several kinds of memories. So let me take a look. It's going to be structure PM. There we go. So it has a stack. So it has a stack memory. Except it's not a preprocessor. Yeah, it's not a preprocessor. It's a part of the translation time. So you have a stack. You have a memory where the instructions are stored, and you have a memory, like a static memory, where you can keep an intermediate values and whatnot. And essentially, there is a pretty interesting feature. You can create a constant hello, hello world, right? And what this does, it actually appends this thing into the static memory. It appends it into the static memory, and when you try to push hello onto the stack, what you're effectively pushing is an address in the static memory to the beginning of the string. And furthermore, it also automatically creates the second binding called hello.length, which gives you the length of the string. And by the way, it's computed at compile time, right? And then you can call something like, actually you can call a native function right, that takes the address and the length, and it can print something on the screen. What's interesting, native is a function that calls a C function. So basically, you can add additional functions to the environment of the virtual machine that the virtual machine can call to, and stuff like that. That's normally how it's done in assembly, no? Or is it, I think, let's see, does. I think that's pretty much how it's done. Yeah, sure. In C just appends the null terminator, essentially. Yeah, pretty much. I re-implemented C, I guess. And here is an interesting thing. Our virtual machine can do a lot. So this program computes Fibonacci sequence. All right. So let me actually remove all of my changes. Let me rebuild everything. The static string gets put into our memory. Yeah. So this is exactly how it works. Yeah. Bin BME. So this is an emulator, right? And then I need to go to the examples. BM, and it printed all of that on the screen. So what's interesting is that, yeah, there is no functionality in the virtual machine itself that lets you just print a number. Right, the only thing you have is a native function write that acts like a Linux syscall write. Just a second. Linux syscall write that acts. This is not a Linux syscall. This is a Linux syscall that accepts a pointer to the buffer and amount of characters. So this is the only a window of interaction for your program in the virtual machine with the operating system. And what I did a pretty insane thing, and I'm not sure if it's worth it. I implemented all of the printing functions myself. So I have a function called dump u64 that literally takes a number on the stack and parses digit by digit, putting it into the memory, into the buffer, and then calls that write function. Furthermore, I did the same thing for dump f64. So I implemented my own printer for floating point numbers. Don't ask why. I don't know why I did that, but I guess I have too much free time. But yeah. So yeah. And actually, I used a very simple algorithm. I used the dumbest algorithm I could find on the internet, which is called like fixed precision fractional something FP to the cube. That's how it's called. It's the simplest and dumbest algorithm you can find. print F64. I think for printing integers in C before, but not floats. Yeah, floats are hard. Floats are hard. But there is a simple algorithm for them. Oh, I also, as an exercise, I implemented this entire algorithm in x86-64. Okay, so... Right, so here's the paper that I used to actually implement it. Yeah, with integers you can just do modulo 10 and stuff like that. So for floats, yeah, I use this algorithm. It's actually pretty simple, pretty straightforward. This is the algorithm in Algol. And by the way, it has a bug. So essentially, this condition has to be checked here first, because it can become true right before the loop. And we actually code that in production. So I implemented algorithm, I put it in production, and in some particular situations, it actually started to overflow and print like garbage. And yeah, I actually had to debug that and figure out that, yeah, there is a bug in this particular paper. And the reason, I suppose, why you have this bug here is because they show this algorithm as a demonstration of a very simple and inefficient algorithm. So basically, the paper is titled "How to Print Float Point Numbers Accurately," right? So they actually consider several methods of printing, and this one was the first one as a demonstration. Like, this is the most straightforward one that you can get, right? So yeah, simple, has bugs. So probably they just didn't pay too much attention to that algorithm because they just put it there for demonstration, for the complete picture of the topic, I suppose. Yeah, but that was interesting. That was an interesting journey, and I learned a lot while doing that. So yeah, that was pretty cool. All right. And I also learned a lot while implementing that in x86-64. I learned about like this kind of instructions. Yeah. So this is, I think it's SSE instructions. Basically, yeah, you just use SSE array to convert like a bunch of doubles to integers and so on. The borrow checker would have caught that. Yes, exactly. Spark loop invariance mine. Yeah. Probably. I wanted to try Spark at some point. Unfortunately, I couldn't install it on my Debian. At some point I was going through the learn Ada core thingy, and I got really interested by their Spark thing, but I couldn't quickly install it on my machine. I could probably spend some time just figuring out how to install it, but I couldn't just, you know, install it from the repos. Ignat is available from the Debian repos, but not Spark for some reason, unfortunately. Yeah, this is a pretty cool website, not gonna lie. So, and especially, yeah, it's kind of funny how throughout the whole tutorial they're constantly throwing shades and at C and C++ and comparing it with Ada. Is just beautiful. It's an absolutely beautiful tutorial. I love it. I was installed from Ada core website. Maybe I should do the same thing. Maybe just download the install. Oh yeah, I tried to download something that was like a GUI installer, and I didn't really trust it that much. So maybe I should try it one more time at some point. Yeah. Alrighty. So, GUI. Yeah, it's kind of like weird when you download a program for Linux and it's a Windows-style GUI installer. It's just like, excuse me? That's what you used. But you use Windows, right? So it's kind of like it's okay in Windows. But when you see something like that on Linux, it's just like really sus. I don't know. Oh, it's installed in, oh, it's in home. Nice. Okay. So that's pretty cool. Oh, I see. Thank you. All right. So yeah, I think I should try it at some point. Maybe at some point I'm going to do a stream where I learn Spark. Spark looks very interesting. So it's like a subset of Ada that is actually formally verifiable or something, right? As far as I know, NUT supports Spark out of the box. Really? I don't remember how do you even run Spark? let's actually go back. How do you run Spark? Overview, key tools. So if I try to prove it, it will show me what kind of command. Okay, not proof. And if I try to run it, nope. I don't have things like not make, right? But I don't have a prove. And this was installed from the Debian. Yeah, I think I'll have to install it properly. It can compile Spark, but it does not include not proof for verifying it. Oh, I see. Interesting. From verify, you need not proof, which does not come with the not package from API on Debian. I see. That makes sense. Otherwise, Spark is essentially just aided with some extra aspects, I think. From what I understood in this tutorial, it's actually a subset of Ada. Not really subset. Yeah, this is a pretty good demonstration, right? So it's a small subset of Ada plus Spark aspects. Yeah. And especially like this thing, where the proof or the specification, I don't know how to call it, is bigger than the implementation itself. And Belgian, thank you so much for gifting tier 1 sub to affirmation. I'm really sorry for mispronouncing your name. I'm really sorry. I don't know how to pronounce names. Yeah, thank you for support, and welcome to our amazing programming community. So yeah, I really like how post condition is basically the implementation, right? So yeah, it's kind of ironic in my opinion. It's kind of ironic. Esther. Okay, I think I will remember that. Esther. I think I pronounced it correctly. For some reason, it kind of reminds me of the sort of like whole-oriented programming in Idris or something like that, where you specify the signature of the function that you want to implement, and then using the environment of Idris, you can go through possible functions that you can fill in for that specific type, and you can basically develop iteratively with the compiler assisting you with how you can fill particular expressions, because it knows what are expected types there. All right, package. Okay. With Spark. Oh, I see. Interesting. Yeah, okay, so I'm gonna take a look at Spark a little bit closer, a little bit later, and maybe we're gonna do stream on it. So sounds very cool. All right, but today is a C programming, unfortunately. Alrighty. So what I was doing, I don't remember. I think I was integrating expressions. Yeah, so this entire virtual machine is 2000 lines of code already. I should start splitting it. So my idea was that I wanted to make a very small virtual machine that will fit into a single file and make it a header only like library in a style of STB. But apparently it actually grew out of its scope, grew out of its initial scope. Yeah. So, and what I mean by STB, I mean this kind of libraries. Nothing's STB. I don't know if you ever heard about them, but these are pretty cool libraries. So essentially it's a header-only library. And yeah, for example, there is a header-only library that can parse PNG, JPEG, and GIF files, but it cannot do animations. Yeah, so it can parse all of these formats, right? And it's a self-contained single header file of the size of 7,700 lines of code, and it doesn't depend on anything except libc. It's completely self-contained and it can parse all of these formats. this is amazing, absolutely. So you can literally just pick this file and copy paste it to your C project, and there you go. You can parse images without installing any additional third-party dependencies or anything like that. So yeah, okay, so you heard about it. Like, I also use it all the time everywhere, even in the projects where I have like SDL, and SDL can parse like some images and whatnot. It's just like easier to use STB. So it's STB is way just better than SDL image. Such a nice idea. And I wanted to like my virtual machine be something of that style, but to be fair, it's only 2,000 lines of code. STB image is 7,000 lines of code, so maybe I shouldn't be ashamed of the size of my files. Alright, so yeah. That's madness, but great nonetheless. Well, I don't think it's madness. I think STB libraries are used quite often in a lot of even commercial games. It's just, since it's a public domain library, people don't have to attribute STB at all. So yeah, STB like used pretty much like in so many game engines and games in general, but at the same time, not a lot of people heard about them. Mighty Lion Vulkan project has a rendered D file which is on 1600 or so lines, and I feel like I'm going insane editing it. Yeah, basically when the size of the file exceeds a particular threshold, you don't care about positions of the function anymore. You only navigate through functions by searching them, right? I know roughly that, okay, so I have a SV something like trim, and here it is. So, and yeah, you start navigating using only search, right? And you basically abstract away from the file completely, which is kind of interesting. Yeah. So, yeah, it's pretty. Okay, so now I need to take a look at how we are storing expressions. So I have a type called deferred operand. This is a very interesting type. Essentially, in assembly, you should be able to jump to a particular label. Let me revert this entire thing. Right, jump to a particular label before it was defined, right? Jump to a particular label before it was defined. Oh, by the way, another interesting thing. So speaking of these directives not being a separate step, if you have a label loop and you try to define a constant loop with some values, right? With some values, and you try to compile that, it will fail because they're stored in the same namespace. So you will never confuse loop label and loop binding, because they are located in the same like scope. And it even tells you that you're redefining a loop, and the first definition of loop was here. So there is no difference between labels and bindings. Label is just a special kind of binding that stores the address in the program memory. Right, so that's like one of the like clear demonstration of this thing not being a separate step, but actually being the translation directive. Would be messy to define loop equals then jump to address 30. Yeah. Furthermore, I think you won't be able to even jump to n. Yeah, you won't be able to even jump to n. I think it will also fail because we have a little bit of a static typing going on. Oh my god. It's actually okay. So you're able to do that, but you won't be able to call to n. I'm pretty sure you won't be able to call to n. Yeah, trying to call not a label. N is const, but the call instruction accepts only literals or labels, right? So we have a little bit of a like static typing going on. So in the future, I actually want to make it even stronger, right? So I'm gonna have like a hierarchy of types. So at the top of the hierarchy, we have number. The subtypes of number are going to be integers and floats. The subtypes of integers are going to be instruction addresses. memory addresses and stack addresses, and for example different kind of addresses are only acceptable by specific types of instructions, and you won't be able to use different kind of addresses in incompatible places, and the translator will actually check all of that. Right, for example, swaps frames of the stack, right, and essentially this is addressed within the stack, and you won't be able to use a program address in there or a memory address because it's a stack memory, not the static memory, right? So, but we don't have that yet. So at some point, yeah, we're gonna have the hierarchy of types. So it's gonna be statically typed, strongly statically typed assembly. Yes. Port AD type system to BOSM. It would be actually very interesting to do something like that. Yeah, the AD type system is very interesting, how you can just take subtypes of particular types and whatnot. All right, so let's continue. Okay, so we have a deferred operand. Yeah, so what I was talking about is that you should be able to jump to the label before it was defined. Because of that, we have a second pass translation. So at the first pass, we collect all of the instructions, and if they refer to a label, we defer resolution of that label. Once we translated everything and collected the addresses of all of the labels, we do the second pass where we go through all of the deferred operands. We even have a type deferred operand, and look up to the labels that they refer to, and then resolve all of the values, and then save all of that to the file. So it's a second pass assembly translator. Yeah. So now, since we're introducing expressions, right? So instead of labels, you can have actual expressions here. This thing should be actually referring not just to the name, but rather an expression. Hello, Erhan Kernes. Did you just join or something? Who neither? Oh, you're okay. You're donating. I see. I thought you just joined or something. Okay, so I think one of the changes I need to make here is, so this is address of the instruction, the operand of which is deferred. This is the name of the label, if I understand correctly. I think. Let me actually rename this thing and see in which places we use that. So, all right, so this is that, and all right, so here it is. So this is the name, and then I use name to, yeah, it's a name of the binding. I see. It's a name of a binding. So deferred operand. It's deferred operand. Yeah, there we go. Cool. Would something like jump loop +1 work? I think so. It should work. Essentially, loop should have a type of instruction address, and adding just a number to the instruction address should result into an instruction address. So I think the literals should be like type neutral, and they can be adapted to any type they interact with, or if that makes any sense. I think it's kind of similar into Ada as well, right? So the literals themselves, they don't really have any particular type, but when they interact with a specific subtype, they kind of become part of that subtype, unless the literal is outside of the range of that type, if I understand correctly. Oh, you were okay. So I'm sorry, I forgot about you. I didn't mean to. But right now, loop +1 doesn't work because we don't have expressions at all. So that's exactly what we're working on. All right, so basically what I want to do here, I want to introduce an expression here. So it's going to be expression name. It's not name, it's just an expression. Just an expression. And we also need to store the value of that expression, right? To make sure whether it's evaluated or not. Or maybe we don't have to. Yeah, we don't have to. So yeah, this is the whole change that I wanted to make. But maybe before I'm gonna actually start pretty intensive and deep refactoring, I want to commit whatever I have already. I think it's kind of dangerous to do it right now. So I just introduced a bunch of types. Yeah. So essentially, yeah, I'm gonna do a very deep compiler assisted refactoring, what I need to do, I need to replace the type of a single field, right? The type of a single field. And that means it's going to break the program in all sorts of places where we use this field and whatnot. And I'm gonna just go through all of the compilation errors and fix them. I call this compiler assisted refactoring. It's just when I change a signature or definition of something, and the compiler just tells me where I have to make the changes. So I use that technique all the time. Flashbacks to my week-long refactoring hell on my Vulkan project. Yeah, I can imagine that. Vulkan actually has a lot of like small structure types that you have to constantly fill in, and a lot of like these functions and whatnot. Kind of reminds me like a more extreme version of WinAPI, to be fair. In WinAPI, you also interact with API by filling up the structures and then handing those structures to the API. It's like very bureaucratic in that sense. It's like you're filling up the forms all the time for something. I never tried Vulkan myself, but I watched some streamers using Vulkans. I never used WinAPI, thank you. But I used it recently actually, and it does feel like that. Yeah, it's like Vulkan, essentially. It's like Vulkan. I'm pretty sure it's designed by the same enterprise people. Enterprise really likes this kind of bureaucracy. Right. Alright, so let me check if this entire stuff compiles. I'm not sure if it compiles. Right now, by the way, the assembly is very fragile. I didn't even plan this assembly to be like a proper assembly or anything. It's just like it naturally evolved into something, and now I have to deal with all of my bad decisions. So I think it's for allowing spec changes without breaking function interfaces, but yeah, who knows? I don't know. Graphics API become more like increasingly difficult to use and learn. Remember back in my days with OpenGL 1.0, we just had to do GL begin and GL end, and that was it. And that was actually so fun. OpenGL 1.0 was so fun because you can literally like learn it within like a evening and just do pretty cool things with it. Now, starting with OpenGL 2.0, you have to learn like shaders and how to set up the shaders and whatnot. It's just, and Vulkan is even crazier than that, and it's just they sucked up all the fun out of graphics programming. Oh my god, to the point that I'm actually thinking, do I need GPU? I can just use CPU, just put pixels around, and it's more fun than that. I don't know. Yeah, it's like 1,000 lines to get the triangle. Yeah. Chip security through obscurity. Yeah. Anyways. All right. Did I commit everything? I don't remember. OpenBM when? Actually, I was thinking, like, how would you implement a graphical application in BM? Maybe it's gonna be like some sort of a special mode where you write to the static memory, and then the environment of the virtual machine interprets that region of memory as a picture and basically displays it. Or something like that. And I'm just realizing that I'm re-implementing WebAssembly, because that's how you do in WebAssembly anyway, right? So in WebAssembly, essentially the WebAssembly program writes a picture into the memory, like literally pixels, RGBA pixels, and the JavaScript that manages all of that just takes this image out of the memory and puts it on a canvas, like every frame, like that. Yeah, and then asks WebAssembly to calculate the next frame, and so on and so forth. Now writing an app in NIM using HTML5 canvas thing, and it's so simple and fun. Oh yeah, I actually saw you stream doing that. I was looking in the chat. I'm sorry. I'm sorry that I didn't say hi. I was a little bit busy doing my chores, but I think I watched it. So you were trying to do like some sort of like an editor or something. Yeah. What is going on in the chat? All right. So is everything compiles? I want to now do a committee. Push it. Right. Add. Oh no, I forgot to create a separate branch. That's right. We have a process. Yeah. I complain about enterprise people and bureaucracy all the time, but yet I have a very specific process where I create a separate branch for each and individual issue. Yeah. Years of Java enterprise development. Compile time math expressions. I think this is what I was trying to do here. I think, yeah. Kind of most of the stream was dealing with 6.5 gigabyte XML file containing all the dictionary. Oh my god. That's a lot of XML. 6 gigabytes of XML file. Oh my god. How do you even parse it? Like, yeah, I usually parse things by mapping a file to a memory and just treating it as a string, because usually it works. With 6 gigabytes of XML, you cannot even do that. Like, you have to like stream parse it, and it's painful. But I mean, if you're using like some sort of special library, it's... yeah, oh my god. That's a lot. Okay, so the number is 172. What's the Java quote about XML? I worked with 50 gigabytes XML file before. Discord music database. Huh. Just each page. Yeah, I see. Okay. When with yeah, stacks is probably way to go for such a big files. Yeah. Is this an XML size competition or something? Okay. Who has the biggest XML? I see. All right. We have a 72. Okay. Introduce Mozilla Dictionary on the wiki pages containing Latin words. JSON result JSON was 200 megabyte, which was a nice saving. Oh yeah, JSON, probably equivalent JSON is going to be shorter, right? Because you can save up on the tags and stuff like that. So with 2 word tags, you're going to have like 1 word key in the map. So, and overall, it saves up a lot of memory probably. And also arrays, like you represent arrays in XML by actually having a tag and a bunch of tags, repeating tags, and the arrays also will compress quite a lot. Yeah. Yeah. XML is extremely verbose. Yeah. Okay, introduce types for expressions. Compile time, translation time expression, translation time expressions. Translation time is a very long word. Too long of a word. Alright, so let's go into state of a deep refactoring. So deferred operand, and what I want to do here is replace expression with an expression. And at some point we're going to have a function that takes an expression and evaluates it to something, and it could be evaluated from a binding. That means it will look up the binding, and so on and so forth. And what's funny is that I think at this point all of the operands should become deferred expressions. Or maybe not necessarily. So we can try to parse the expression of the operand, and if the expression is not a binding, we can right away assign it and not defer it. That makes sense. YAML versus JSON, what do you think? I don't think about it too much. Sorry. So according to their descriptions or whatnot, you probably want to use YAML for configuration files and JSON for transferring data between JavaScript programs, because that's exactly what these formats were designed for. So, right. So JSON was specifically to be designed a subset of the JavaScript. So JSON is also JavaScript, and YAML is designed to be human readable, so that's why you want to use it for the configurations. But I'm just citing the descriptions of the format themselves, right? And okay, so like I don't see too much room for opinion here. The usage, the purposes of the formats are described in the definitions of the formats. So again, not much room for opinion here. Like, it is what it is. You use a hammer to drive a nail. Cool. So we don't have an expression here, so this is probably because I want to put... Yeah, I need to actually put it a little bit higher, I think. Such a formal enterprise answer. Well, I mean, it's not that interesting of a topic, to be fair, right? You have a format, and format was designed for a specific goal. Okay. Oh, so I don't know, maybe there's something wrong with my brain, but I just don't find this kind of things interesting. Out9, what's up? Hello. Welcome to the stream. Very glad to see you. What's up? What's up? Alrighty, so let's actually push this stuff here. So here is the name. Aha. Okay, so when we're pushing a deferred operand, we're not pushing a name anymore, we're actually pushing the whole expression there. Oh yeah, this is a new PogChamp, by the way. This is a new PogChamp. I think I actually revived the bot today. PogChamp. Yeah, there we go. It actually rendered really well. Because there's like a contrast line, so that actually makes it really easy renderable. Alright, so I think I need to now rename this entire thing. Yeah, so we have a bot that actually takes an emote and Brailleizes it. I don't know, it's not really ASCIIfication, it's really Brailleization. So this algorithm was written in Haskell. I think this is how it's called. I forgot the name of the library. Alright. Hello, Jan Punthong. Please don't bully me. Yeah, I won't bully you. Hello, how are you doing? How is your journey on becoming a better developer? It's not bullying, I'm just curious, generally. Just curious. Oh, here it is. It's just a small library for Brailleizing images. Right, so essentially you provide image.png and it produces this thing, and it's written in Haskell. Yeah, so it's purely functional. So for anyone who's interested in this thing. It was actually a long time ago, it was 2 years ago already. It was almost yesterday when I was struggling to implement this algorithm. And yet, it was 2 years ago. Yeah, I was using like beat masks and whatnot. It's actually pretty cool that Haskell has like binary literals, and yeah. Currently, I'm learning Django. Interesting. It's one of those Python frameworks. I thought in 2021, like Flask is the new hot thing in Python. I thought this is the... To be fair, I don't know. If you're only learning things, maybe it would be easier to learn Flask instead, because it's just like a more lightweight and simpler. I don't know. I'm very biased. Yeah, binary literals, like these ones, and they're part of the Haskell. Like Haskell does have them, so yeah, you can parse like bits from the integers in Haskell and stuff like that. So that's pretty cool. It's a very messy code, because I couldn't understand how to translate my imperative idea into functional code, but it worked out at the end. There's such a lifesaver writing my Risk Simulator at uni. They make bit masks so much easier. Yeah. Alright, so I have a library called AIDS because it's supposed to be a replacement for C++ std. Right. And I implemented UTF-8 encoding and decoding there. Well, I mean, yeah, so the standard library of C++ is called std, so I made a replacement for it, which is called 8. And wait a second, where is it? I think I used the binary literals. I know I'm a horrible person, I'm sorry. So, and this is how it looks like. Essentially, in UTF-8, you have to extract these clusters of bits to get the Unicode code point, right? So there is like a pretty cool picture on Wikipedia. Yeah, there we go. So this is how this cluster look like. Depending on the size of your UTF-8 character, you have to extract different sizes of these clusters of bits and then concatenate them, and here's your Unicode code point. So in C++ with binary literals, it's actually as simple as that. I can have like separate masks for these clusters for different sizes of literals, just extract them and easily concatenate them. So yeah. Yeah, that's pretty cool. It's a picture of table. There we go. Now it's a picture. So this is a picture now. All right. Let's continue. We are in a state of a deep debugging. Not debugging, but refactoring. Right. Oh yeah, Ada has like pretty cool literals where you like specify the base or radix of the literal, and yeah, you can just use whatever. This is so cool. Yeah, I saw that. It's so new. Common Lisp also has that. Nice. All right. I wonder if you can even customize the digits that you can use for specific literals. It will be interesting. 69 book, yes. All right, so here's the name, and I need to change the signature of this thing, right? So I'm pushing the address, and I need to push an expression here, the deferred expression. So, yep. This is an expression, this is an expression. So, and I might as well just do it like this, expr. All right, so let's take a look. So, and now we are translating a literal. So here is the operand. Yes, I see. So we need to get rid of the boson translate literal. That's what we need to do. Boson translate literal. Instead of translating literal, we have to parse operand as an expression. And I wonder, do I have parse expression from SV? I don't have it, so I'll have to implement it myself. All right. Ada max base is 16. Oh, that's pretty sad. But it is what it is. From SV. So we're gonna provide the arena. And we're gonna provide a string view as well. So this is gonna be the source. So essentially, we take the line, we detect that the line is an instruction, we extract the instruction name and the operand, and we treat the operand as an expression, and we parsing it as AST. So that's going to be the idea, essentially. I don't know if I ever needed a higher basis for 16. The only case I can think of is some sort of cryptography reason. So maybe you can take some values and translate them to like some sort of big prime base for obscurity reasons or something, maybe. But apart from that, I can think about any other use case for them as well. From tokens, okay. But also I'm not a cryptography guy, so I don't know, to be fair. Okay, so first thing we want to do, we want to allocate tokens. So here's the tokens, 0. So, and then we need to call tokenize. Tokenize. Alright, so here's the source, and we provide the pointer to the tokens, and it will fill up the structure with the tokens. Nice. Once we have the tokens, we want to transform that to tokens view, so we can easily just take a look at the subsequence of tokens. It's going to be called TV, tokens as view, and it's going to be just a pointer to the tokens. I think there's one person in the world that actually understands cryptography, and they just get to tell everyone else how to do it. Yeah, probably that's how it goes. Alright, so parse expression from tokens, and we're going to provide the arena for memory allocation and the pointer to the tokens view. Alright, so I think I saw, yeah, I saw this, this thing here. So this one is going to be kind of interesting. So parse expression from SV, and what I'm essentially doing, I'm using operand to parse this entire thing, but also I need to provide the arena, because the parsing will allocate memory. And then we're gonna have operand expression. So here's the operand expression, and the only time we want to defer the execution of that, the evaluation of that operand, if the operand expression kind is binding, at least right now. So yeah, so if it's a literal, there is no reason to defer it, because literal is equal to itself. Evaluation of a literal results in itself, so we don't have to defer it ever. But if it's a binding, it could be kind of difficult, because we may not know all of the bindings yet. So here's the expression. Expression what? Expression kind binding. Yeah, and only then we're gonna try to defer it. This is what NSA did when they forgot to mention a weakness they found in a standard crypto implementation. Oh yeah, I think I heard something like that. Yeah. So they intentionally just didn't say about weaknesses in some of the implementations, and just keep that to themselves for the future. The thing that surprised me at some point about NSA is that they have a GitHub organization where they upload their open source projects. It's so cute. Oh my god, it's so cute. This is where they uploaded Ghidra, right? So one of the popular reverse engineering tools that everyone uses, which is written in Java. And yeah, look guys, we're doing open source. Oh my god, it's just so adorable. Like, yeah. NSA is so open, yes, exactly. The FBI would rather let some child abuser free to explain the method than catching them. Probably, yeah. I know nothing about FBI or NSA, to be fair, because I live in the middle of Siberian forests, so. Sharing is caring. So they share their source, so you won't be mad when they share your data. Anyway, so modules in why cryptographic algorithms are complex than what's specified in detail they use. I don't know. Don't worry, Zuzin, NSA knows everything about you. Cool. Even I don't know everything about me. At least somebody knows everything about me. That's pretty cool. So this is not BAMS. It's BASM. That's what it is. So we have operand expression, and if yeah, operand kind, we want to defer this entire thing, and yeah, we're gonna remove this entire thing now. So this is a simplification. KGB also has its own GitHub page, really. So just a second. Oh, nice. That's pretty cool. Well, it's actually a personal account. Well, I mean, KGB didn't have enough funds to actually pay for the like a premium organization account or something. So yeah, that's why. Oh, it's not a thing anymore. Damn. Yeah, right now private repositories they're free for everyone, aren't they? Or even organizations, or maybe they are not free for organizations. I don't remember, to be fair. But I remember one thing, so sometimes organizations just don't want to pay for private organization repos, so instead of organization page, they create a personal page where private repos are free. This is so funny, like, yeah. They're free for no, yeah, some organizations actually do that. And so knows a lot about love. Okay. So another thing, I wanna try to do... What's up, Yatanasa? Welcome to the stream. If the expression kind is lit str, which means string literal, we also need to push that string into yeah, we need to push it into the... Oh boy, into the memory. So similarly how the BASM translate literal does that. So effectively, this entire expression thing eliminates the BASM translate literal. And I had a lot of problems with this particular function, so that means I'm on the right track. So it's kind of funny. Like, I had the functions that always gave me so much headache, and then I'm switching approach, and while refactoring to the new approach, this function becomes obsolete. Does that mean that I'm on the right track? I think I'm on the right track. I think. So what I was doing here, when it's a string, oh no, that's very interesting. So I'm not pushing that string. Where is the string? Oh, here it is. So yeah, I need to push string to the memory. Yeah. I need to push string to the memory. All right. So parse expression from SV. So if this thing is a string literal, right? We'll have to push it there as well. Okay, so it's deferred operand, then I take the operand expression value and as string. I think it should be as string, as lead string. Yeah, as lead string. And that thing should return me the output, and that means I need to set the value. So, and the value is going to be essentially this. So I set it to just this. And the, yeah, so it has to be just like that. Which is pretty long expression, but I mean, there's nothing I can do about that. So how much time do I have? Alright, so I want to make a cup of tea, to be fair. Should I call my enum ABI for application binary interface? You can call it app-bin-int. So basically the best from the both worlds. Shortness and descriptiveness. But int makes it sound like it's an integer. depends if you're using C or Java. Length, clarity, probably. But there are some established notations, right? So I think ABI is very established word. So yeah, why not? Majority of people will understand what it means. Going to short war names in C is such a culture shock after Ada. Oh yeah, so in Ada you're supposed to like write poems in the function names. So, which is kind of cool actually. So they're very descriptive. Okay, so here's that. I push binary to memory, and if I remember correctly, this function returns the address, doesn't it? It literally returns a word. Value as a string, and there we go. Otherwise, depending on what we're doing here, I think I'll have to extract all of that to a separate function. I'll have to extract all of that to a separate function. So maybe I'm gonna use switch here, and it's gonna be operand expression kind, and it's gonna be like this. It's gonna be case expression kind binding, and I'll probably have to repeat this entire stuff in all the places where I have to call parse expression from SV. But I don't think I call it in too many places. Wait a second. Well, it just depends where I'm trying to extract the... Oh yeah, okay, so that means I won't have to do that. Do we want to port your program to push cards? Nice one. Punch cards. Is there like any modern punch card readers? That would be actually kind of cool. Imagine like a thing that you connect via USB and just take a deck of punch cards, just put them there, and then you can mount this device as a, as an additional file or something, or maybe like it appears in the device folder, and you cut it and it shows you the contents of the deck of the punch cards. That would be so cool. But I don't know how huge such punch card reader would be actually, because it needs to go through the cards, it needs to like probe whether there's a hole or not. Like how huge is it gonna be? It's like box. Yeah, Def Punch card, exactly. That would be actually pretty interesting. Calls API. Yeah. We need that for research purposes. Alright, so then case expression kind lit. Okay, so let's put it here. So now it's a switch case. So what other kind literals do we have? So it's gonna be expression kind lit, and yeah, this is the rest of the literals. And in case of characters, yeah, we treat the character as just a number, so ASCII code of the character. And I'm gonna query replace this stuff with that. And let me think what's gonna happen. So in case of an integer, I'm just gonna treat it as, yeah, this size. So this is a word, U64, and operand expression, in that case, is going to be as lit integer, int, yeah, there we go, so word U64. Alright, that's pretty cool. Similarly, why did I remove that? I didn't want to remove that. It's going to be F64, float, and char. Okay, char is gonna be the most interesting one, I think. I guess it's gonna be like this, where I just use char and I convert it to U64, and negative char is probably gonna be just reinterpreted as a, you know, as unsigned value. And yeah, so essentially we're just evaluating the expression. Or maybe I just have to come up with a function that takes an expression and just evaluates it, and yeah, depending on these things, it will just return different stuff. Oh yeah, and that automatically will... Wait a second. I think I accidentally implemented a feature that I wanted to implement for quite some time. Wait a second. So you can define strings as bindings, right? You can define strings as bindings, const hello. And I was thinking, why can't we have anonymous string where you could just do push hello, which automatically at the translation time adds this thing to the static memory and replaces this thing with the address of the function. I think I accidentally done that. Okay, so why not? And it will just work. Though after that you won't be able to access the length of the string, but yeah. For example, if you know the length, like hello, you can just do push hello, push. All right, so we talked about NSA, and look what happened. So let's not talk about NSA anymore, okay? So I think they heard us. All right. So yeah, I'm gonna blame NSA for that. Okay. Stop saying NSA. All right. I think I want to actually go to the kitchen and turn on the kettle. What do you think about NSA? I'm glad that my tax money are not going to fund NSA. Because I'm a citizen of a different country, so yeah, cool. But I mean, they're probably used for wars anyway. So yeah, I'm gonna quickly go to the kitchen, just turn on the kettle, and I'm gonna be back. Hello, I'm back. Two back. Champion of the arena. All right. So I want to kind of extract this entire thing into a function that will be called evaluate expression. And to evaluate expression, what do we need here? Evaluating expression will always return a word. Which is kind of cool. Right. So I'm just thinking where I'm going to place it. Expr. So here are all of the functions. To be fair, it has to be placed after bosom. Yeah, somewhere here. So it's going to return word bosom eval expr. It accepts the bosom context and it also takes an expression. So to be fair, we can pass an expression by a constant pointer because you don't need to modify the expression itself. Right. And remember, I love myself too much to commit. What the hell are you talking about? Translate source. Yeah, I should have not talked about NSA because the chat becomes... Every time I talk about something slightly political, chat just goes crazy on politics. And I'm not a political person, I just don't like to talk about that. Why do I talk about that if I don't like to talk about that? I guess that's the trap of politics. Yeah. The trap of politics. You want to talk about politics even if you don't like to talk about politics. So yeah, you cannot avoid that. So it's the trap that you fall into every time. Alright, so it's gonna be switch. Oh, my tea is ready. So just a second. Just a second. If you don't like talking about it, then you're talking about how you don't like to... Exactly, exactly. Which kind of makes you talk about politics? I don't know. Yeah. It's a really strange topic. Mysterious topic. Expression kind. Yeah, here are all of the possible expressions. So, in speaking of binding, well, keys. So, and this is where I have to, I want to do all of this stuff, where if it's a binding, I need to look up the binding itself. So I think I do have something like a resolve. Yes, we do have resolve binding, which is beautiful. Yeah. So, and this is where we're gonna put all that. That says a lot about our society, yes. Chat. Where do we live? Who knows where do we live? Sorry. Expr, what is that? Expr value, I think. As binding, yeah, so as binding, and that should return me a binding through this entire thing. So and then, oh, and we need to know, so this is uses the location. Oh, that's very interesting. Unknown binding. So when we are evaluating the expression, do we not want to know where exactly the expression is located? That will be actually very useful, I think. So maybe we're gonna accept the location, the file location, like this. So it's file location, and the file location could be very useful for reporting things, like, for example, right now, location. A file location is essentially file name plus the line, and when it's printed, it just prints like a nice formatted string. Alright, so now we're gonna have this thing, and so the name I'm resolving is in fact this thing. So we always know exactly the place where we where we do all that. Okay, if the binding has been successfully resolved, we need to return the value of the binding. And what's the value of the binding? I think it's something like Yeah, it has a value. Yeah, we literally just return binding value. Nice. In case of int literal, we can just return expression value as lit int word use64. There we go. Cool. Then we return word use64 expression value as float, as a lit float. This one is gonna be a character. And the string is gonna be... Alright. Oh, and string will involve actually pushing that string into the memory. Yes. Kawaii desu. And boson push string to the memory. Yes. And pushing string to the memory, what does it return? It returns a word. Okay. Actually, we can just call it result, I think. I think it makes more sense. Lit context. I have to ask what lit means in this. Literal, yes. No, we're talking about lit things. Yes. It's just like it's already a pretty long name, but, you know. I could call it like case expression kind literal integer. Something like that would look okay in Ada, I suppose. Yeah. So, or for example, expression kind literal floating point number IEEE 7754. So that's also a pretty good name for an enumeration. Yeah, I really like this name. It's a pretty good name. Oh yeah, by the way, I'm using French press to brew tea. This is what I was talking about. Yes, I'm really sorry, Esther. Yes. I don't have a teapot, okay? So I just don't have a teapot, and it's pretty convenient. Yeah. In it just be literal floating point number. Oh, okay. Okay. Oh yeah, you also have to capitalize it like that. Wait, how do you do that? Yeah, like this. Yeah, this is how it's gonna be in Ada. Exactly like this. Probably not. Aren't in a global namespace. Ah, okay. All right. Oh, Adamod does this for me. Yes. Teapot 754. Is this C or C++? This is pure C, by the way. To the point that you won't be able to compile this code in C++, because C is not a subset of C++, and C++ is strongly typed. Like it's stronger than C. So, for example, we have situations where we call malloc, right? And I think malloc like that will just work. Yeah, but I think in C++ it's not gonna work like this. Right, it works in C, but in C++ you would have to explicitly cast this thing, and in C++ you would probably have to use a different kind of cast, right, a static cast, to be idiomatically C++, but... And surprisingly, my editor highlights it. Oh, because it uses C++ for header files, I see. I forgot about that, but yeah. It is C. But in C you can just take any void, right? You can take any void star and apply it to any pointer and it will just work. You cannot do... Yeah, I think you can easily convert between any pointer and void and back. But you won't be able to, for example, to assign int star to float star. I think C may actually complain about that. But between any pointer and void star, it usually works fine. But not in C++ though. Reinterpret cast for the win. What does cast think mean in C++? Just use C-style cast. Yeah, C-style cast in C++ specifically, it just tries each cast in sequence until it hits reinterpret cast and then does reinterpret cast. Oh shit, yeah, it's not IEEE, you have to do Institute of Electronical and Electronics Engineers. Yes. Oh my god. Reinterpret cast is so verbose and I'm another programmer. So the idea of these casts, I think, was to make them as awkward as possible, to discourage casting at all. So from the point of view, I think Strauss-Troop or other C++ designers, it is a bad design if you have to cast a lot between the types, right? So that means you didn't come up with the proper set of types to describe your domain that you're working in. So so they try to make the casting between the types as discouraging as possible, so to force you design properly types or something. I think that was the idea. So that's why it's so verbose. Especially reinterpret cast. Is that actually real or a joke? This is something that I heard, but I might be wrong. Most of the casting I do is static cast vector to compare it with ints. And that's okay. Static cast is actually pretty good because it will fail at compile time if things are not castable. Yeah. And I'm sorry for the bot. It thinks that you send a link and you're pretty new here. Maybe not, I don't know. But yeah. Is it actually real or complex? It's a good question. Gray face, no space. Alright, so what I was doing? I forgot what I was doing. Debated. So defer operand. Oh yeah, so I don't have to do that anymore. So we parse the expression, and that's a pretty cool thing. If operand expression kind is equal to expr kind binding, Emacs, please stop. Jeez. Remember when complex numbers were taught to me in high school and I used them precisely once in uni ever? I remember I actually used complex numbers in uni quite extensively when we had electrodynamic course. Yes. Specifically because we were looking at different generators and how they work, and majority of the models that describe alternated current generators, they involve imaginary numbers because it's the easiest way to describe cyclic repeating things, right? So instead of like working with waves, you essentially work with a single vector in the complex space. So, and that's why all of the models that describe these kind of things, they use complex numbers because it's just easier. But apart from that, I think I didn't use complex numbers anywhere else. And that course was awesome by the way, because the teacher was so cool. She actually explained everything so well. I really like that course. It was for like AC or something. Zip. Yeah. So basically, from what I understand, complex numbers are extremely useful for expressing periodic things, right? So if you have something that happens like periodically, or oscillating, right? Oscillating, you may want to use complex numbers to describe that. But that's not the only usage for complex numbers. I think there's more than that, but it's one of them. Nuffly, what's up? Quaternions, yeah, quaternions are, yeah, also a thing. And they also gave us Mandelbrot set. Yeah, that's true. I never actually implemented Mandelbrot set. I just realized that. I should definitely do that because it sounds fun, right? And the imagery that you get from it very cool. It looks nice. Everyone likes it. I get that case, there's some black magic relationship between I and Pi, but it's beyond the grasp of mere mortals such as myself. Same, seriously. And even when I was going through that course on electrodynamics, I was just treating that as a black box, right? So it was just memorized how you transform things from one description to another and some formulas, and I was just, you know, just treating it as a black box, and magically worked. It just worked out, so yeah. It's like, it kind of reminds me one of the Provod streams. Provod is another Russian streamer who streams here, and he's doing, I think he's doing Vulkan right now. Yeah, and he's like an ex-physicist, and he said, so at some point the conversation went to the quantum mechanics interpretations, right? So, and different kinds of quantum mechanic interpretations. And he, as the ex-physicist, said that his favorite quantum mechanics interpretation is shut up and solve the equation. So, essentially, don't try to think about it too much. Just solve the goddamn fucking equation and the math will work out. So, so it's kind of the same with the electrodynamics, yes. It's actually true. It's the best interpretation of quantum mechanics. Shut up and solve the equation. So beautiful. Absolutely beautiful. So, okay, so here's the binding. And we need to defer this entire thing. Alright. So program size, operand. It has to be operand expression, actually. Just beat it with the hammer and you'll be satisfied. Yeah, probably. And if it's not a binding, we can straight up evaluate that, I think. Don't think about comprehending or many words, and just calculate it, just solve it. Alright. I think I need to make a small break, actually. Just a second, I'm really sorry. It's gonna be like 2 minutes break. Alright. Alright, let's make a small break. You guys have fun. Alright, I'm back. So, almost on time. Yes, I'm getting good at it. Imagine a programmer actually getting good at time estimations. That's amazing. MX small break. Well, I can... Well, technically, I can create, how is it called? The snippet, right? So, yes, new snippet. Right, its name is going to be SB, small break, key SB. And the thing we're going to do small break. And then we're going to put, like, I don't remember how you do that. It's just, yeah. Minutes. And then we're going to put, like, space in here. But what's funny is that the amount of spaces here will depend on the length of this thing. So we can leave it like that for now. I don't remember if it has to be 0 or 1, but yeah. So this is MIT and this one is going to be just SB. Alright, so now when I go here and I do SB, and I can do 2 minutes, yeah, and then it just works. And actually, yeah, it actually put several spaces in here. So, and MIT, do I have a special key? I remember that I had a special key for somewhere for CMod. For the main, maybe it's not the main, it could be C-like syntax. I forgot where it was. I think it was for make, yeah, it was for make. Yeah, so expand environment fixed, so it's gonna be like that. And what's cool is that you can always like have Lisp expressions here. You can have Lisp expressions, so essentially we can just use this as a variable and calculate the amount of spaces based on the value that you put here. But that could be pretty complex to do. Yes, reload all. Yes, reload everything, and if I try to do something like this, it's gonna be SB, and then 2 minutes, right? Yeah, so it kind of works, but not necessarily. And because of that, so fundamental mode SB, so I think it has to be 1. So, and I forgot how you put Lisp expressions there. Just use log 10, yeah, probably. So in MIT, for example, yeah, you just wrap it in these things, but then I don't remember how you reuse the thing that you input there. How do you reuse the thing that you input there? Okay, so in Emacs Lisp, you can probably convert something to a strings. Integer to, yeah, you can do literally integer to string. Int to string, right? And then you have a number. Well, you don't need to do that because it's probably interpreted as a string. All right, so at any point you probably can take a length of your string, like hello, right? And it gives you that. Then you need to repeat this stuff several times. I think there is something like string make or just string, and you have to provide the character. Maybe string. Something string. String make unibytes. Emacs Lisp make string. When define string predicates, yeah. Oh yeah, you can do make string. So essentially you can do make string and like this. Can you use like a space in here? You can, yeah, essentially you can just duplicate that. But what about the space though? Can I do it like that? Can I do the space? I cannot do that. It's unclear how to provide a character that is a space, so it probably has to be like this. And oh, it literally works like that. And then if I try to do it like this, it doesn't work like that because it's not finished. That's a very weird syntax, but okay, I can work with that. So then we have what? 1 So we have at least two spaces because that gives a space and that gives a space, right? So that means I can replace this entire stuff with this thing, right? Where I take a length of 1 and I actually want to add 2 to this entire thing. And I think that may work. I think that may work. Okay, so if I do yes, reload. All right, and I'm gonna go here, and now if I do SB, it didn't work. Symbol, value as a variable. Okay, I don't remember how to refer back to yes snippet, like a thing that I'm inputting actually here. Yes snippet examples. Maybe I can use some of the examples in my folder, but yeah. That's a very funny things. Yeah. You can have that, but within the quotes, I think I want to refer to them within the quotes. But I don't see a way to refer to them within the quotes. There should be a way. So where are all of the quotes? There must be. I feel like there's no way to do that. Yeah, it feels like there's no way to do that. Because that means you have to reevaluate the function every time you modify that variable, and that could be maybe quite expensive, so that could be the thing. Gamoza! Oh my god! Thank you for 10 months of tier 1 subscription. Thank you so much, and welcome to our Snippets Club. We're just on a huge tangent trying to come up with a snippet thing, but yeah, I don't think I can do that within the plugin that I'm using. Current time string, so this is the time. Is there an option to call CB with an argument? I love tangents, yeah. I guess they're fun sometimes. Wait a second. So you can do things like that. Oh my god. Oh! Yes text. Oh. Can I refer to... But isn't it... Oh my god. So we can make a string. I think that's the case. I think that's what you do here. It's literally our example. Wait a second. It's literally our example. I found it. We found it. Didn't we? I think we did. So what was that? Emacs snippets fundamental SB. And I think that's what we want to have here, right? So we do that, but instead of this thing, I'm gonna just put a space in here, and I'm gonna replicate this thing the second time. So I think that's the snippet we want here. Okay, so I'm gonna reload everything. Please reload everything. And now I'm gonna do a small break. Oh my god, I did it. Okay, I mean, with the help of the thing, of course, but just a second. So it's gonna be SB, and on top of that, we have to do it like that. +2, right? +2. So +2, like this, and yes, reload. Yeah. And now, if I try to do small break, 1 minute. Yes, because essentially every time I input text, it re-evaluates these two prefix expressions and pads everything accordingly to the length of the string. So if I need to go for 3 minutes or maybe 10 minutes, and so on and so forth. That's actually pretty cool. And then I have to press like space or something. Yeah. So the point here is that I want to align small break with minutes, so it looks a little bit better. That's amazing. So apparently yes snippet can do that. Yeah. So you can essentially evaluate like arbitrary Lisp expressions to get some text to insert there. it drives me insane that it's not centered. What do you mean? It's not centered to the size of the screen. I usually do something like this. I usually just bring the zoom to the point when it looks centered. So almost. Plus length minutes. Oh, you mean like that? Like this? Maybe? Like this, I don't know. What the hell is that? Something broke miserably. Yeah. But yeah. That was... do you speak out loud when you program? Yes. Like speaking out your thinking process. Yes. I streamed for so long, I'm literally incapable of programming without saying anything. So... Alrighty, so let's continue. So... Oh, yeah, goddammit, why do you have to actually expose me? Yeah, I do that while cooking too. Yes, when I'm cooking, I feel like I'm on a stream and I'm actually explaining everything I do while cooking like on a stream. And I never did a cooking stream, by the way. I waste content pretty much every day by cooking myself breakfast. Yeah, cooking stream. Like I need to... First of all, I need to clean up my apartment, the kitchen, right? So, second of all, I need to set up everything on the kitchen, and then maybe I can show you how I cook a bowl of rice. Oh, it's not very exciting. Like, yeah. So I can show you how to cook rice with tuna. Well, tuna doesn't require any preparation. I just use the canned tuna, and the only preparation I do is just open the can and just put it on the rice, and then I just eat rice with tuna. It's actually like it's a pretty cool, good combination. I can also show you how to cook buckwheat. You literally cook it the same way as you cook rice. Maybe I can show how to fry a chicken breast. I don't know, so stuff like that. So I don't know. I don't cook anything super complex these days, to be fair. 2 recipes for the price of 1. Yeah, so I mean, it's literally the same. You just swap a rice with the buckwheat, and yeah. Anyways, so now we have a snippet for small breaks, and yeah. What's the programming equivalent of cooking rice? Only if you can compare cooking with programming. So... Well, you may say that in programming you also have predefined recipes, but it's usually... yeah. Well, can you compare programming and cooking? I think you can. You have predefined recipes, but you can deviate from the recipes to achieve a very specific result. But it's still relying on, you know, well-established patterns anyway. So equivalent of rice cooking in programming would be probably iterating over an array, I think. Yeah, I think that's an equivalent of cooking a rice in programming, just iterating over an array. Anyways, so useful. So I personally believe that programming is not particularly comparable with other professions, because I think it's a new kind of profession, like completely, that is by itself. It's really difficult to compare it to anything else. The closest, in my opinion, you can compare programming to is maybe like lawmaking, because in that, and yeah, we slowly go into the politics. Because basically, in case of the laws, they're programming a big dynamic stochastic system, and yeah, I don't know. It's kind of difficult to compare programming with anything else. Hope my rice isn't overcooked by the time the chili is done. Yeah. Alright, so what I was doing, I don't remember. I was doing the snippets. What kind of expressions are we parsing? Next question. No, not really. I'm thinking more of a classical, you know, expressions. Mainstream programming language expressions that look like this. How would you call such expressions, by the way? Right, we have a name for S expressions, right? Something like plus, 1, 2, 3, and then minus and whatnot. Right, so these are S expressions. How would you call expressions like this? Maybe you can call them M expressions? Yeah, so L9 also had the same thought. Yes, technically they're M expressions. Why M? Meta expressions. So the idea was that S expressions are not going to be the final syntax of Lisp. The idea was the S expressions were supposed to be like intermediate representation for like debugging things, and the actual syntax of Lisp will be M expressions. But for some reason S expressions stuck. And M expression is just S expressions where like the first element moved like outside. Right. So here is the list and here's the function application. So in M expressions, there is a difference between function application and a list, right? So in S expression, here's the list, right? And here's the function application. There's not that much difference between those things, but M expression explicitly distinguishes those, if I understand correctly. Right, and technically this is an M expression, but they with you know, braces swapped with parentheses. Yeah, relevant details. So that's what we're parsing. We're parsing essentially M expressions. All right. So if this is a binding, we don't do anything. If it is not a binding, we take the expression, boson eval expression. We provide this thing. Then we provide the operand expression and also the location where the expression has happened. Nice one. All right. So this one is going to be operand. I think this is how we have to do that. Not sure if it's going to compile and everything, but we'll see. Of course it's not going to compile. Incompatible type, operand expression, expected expert, but element. Okay, so that means I did something wrong here. So yeah, it's supposed to be wait a second. Yeah, it has to be a pointer to the expression. A pointer to the expression. Deferred operand, and I think it also has to be pointer to the expression. Which makes an interesting point, so yeah. By the way, speaking of M expressions, I think M expressions, like the functors in Prolog, are essentially M expressions, right? Because, yeah, in Prolog, you can have things called functors, which are literally this, right? And this is not a function call or anything. This is a literal, this is a value that you can pass around. And that value stores the name of the functor and its arguments. And at any point you can take that functor, check its name, check its argument, and maybe create another functor and maybe do something else or transform the functors and whatnot. So, I think this is as close to like intended M expressions as you can get, like in Prolog. Yeah. Well, this is another emote, I think. Pretty sure that's what it is. Okay, bye-bye. Bye-bye, sir. See you. Thank you. Thank you for the rate. Thank you. Oh, no emote found. Okay. Very well then. Alrighty. Let's continue refactoring. So when we're deferring an operand, so a conflicting type, I'm pretty sure I updated the signature here. No, I didn't. I didn't update the signature here. Alrighty. So, and then too many arguments for this function, and this function also should take the file location. Alright. Okay, cool. So now we have the second pass. Oh, yes. Nice, 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 nice. So now, oh, that's so cool. Alright. So this is going to be an expression. So here's an expression. And it's going to be pointed to an expression. And we don't need to resolve any bindings here anymore. I think what we have to do oh yeah, that's very interesting. So we need to be able to have like types of bindings and whatnot. Oh, that is very interesting. So now we need to extend the type system of an expression, and instead of having a kind, on top of having a kind of expression, we have to have a type of the expression. That's actually very interesting. So we're gonna have like a proper statically typed programming language instead of assembly, but it's still gonna be assembly. It's still gonna be assembly. Isn't that amazing? I think it's gonna be amazing. So, and so we have a kind of expression, right? And I need to introduce the type of the expression, right? Expression type. There it is. An expression type is going to be a replacement for binding kind. So we had binding kinds. Yeah, so we're not going to have that anymore. Binding kind is going to be expression type. It's going to be expression type. Think. Yeah. So an expression type is going to be either... It actually depends. Yeah. Integer, it could be integer, it could be... Yeah, so I think I'm gonna just add this kind of information there. Oh boy, oh boy, oh boy. I'm thinking if it's gonna be actually easy to change. Because certain times, so I looked into cooking rice would probably be printing 2 characters in chef. Probably. Expression kind. Where's the expression kind? So that's pretty cool expression. So let's introduce enum expression type. Expression type, and it's going to be either just a constant, or maybe, yeah, let's just call it either constant or label or native. Why not? So binding. I'm really hungry, actually. So it's also used for bind value. When you bind the value, you actually put a word in there, and I was intubated. You know what? I need to finish this thing. So I'm kind of tired, but I want to finish this. So I think I'm gonna keep pushing them. So I suppose I'm gonna literally rename binding kind to expression type, expression type, and that's what we're gonna have here. So it's gonna be const, and binding kind will go away, and we're gonna continue doing this thing. Expression type. Alright, let's try to recompile that. And do we even use binding kind as sister anywhere? Typing function. Oh yeah, we do use it. We do use it. So it's gonna be, let's quickly rename that. It's gonna be expression type. Expression type as sister. Okay, in all these places where we try to do that. And maybe it makes sense for me to replace binding kind with expression type. We'll see how it goes. This is already dangerous. Yeah. So when I do a binding, alright, binding should contain a particular value. It should contain a particular value. But that means that I'll have to... Okay, so that's actually properly fine. So yeah, let's call it a type. Yeah, it's going to be type. Because later the binding will contain an actual expression. Yeah, because in the future we're going to have such thing as const n 30, then const m n plus 50, 60, and so on and so forth. And you know what's going to be the coolest thing? We need to be able to handle these kind of situations. N and actually M and N. So we'll need to handle this kind of stuff. And I have a couple of ideas on how to do that. So essentially, we're gonna have deferred expressions. We're gonna have deferred expressions. Yeah, we already have bindings, right? And bindings are going to be lazy in some sense, right? So they're going to be lazy. They're going to store the expressions that they need to evaluate. When you try to resolve a binding, you start to evaluate that binding. You start to evaluate that binding, and while evaluating that binding, you evaluate more bindings, and you basically do a DFS, right? You basically do DFS. And as you do DFS, you can mark the bindings that you're currently evaluating, and if you hit one of the marked bindings, you hit a cycle, and then you can report that you have a cyclic definition in the bindings. So it should be pretty straightforward, I think. At least I don't see any very dangerous pitfalls in that regard. So I think it's gonna be cool. All right. So this is gonna be actually type, expression type, and in that case, I think we can safely replace binding kind with expression type. I think it does make sense to do that. All right. So is there space for Java questions? Come on, hit me with your best Java question. I don't guarantee that I'm going to answer it, but I mean, we can try. Okay. So this one is going to be expression type. So maybe I'm going to just query replace like binding expression type. That's a very bad. Oh my god. Okay, that's that one, that one, that one, that one, not that one. Okay. Okay, so you're trying to resolve a binding, but yeah, we shouldn't try to resolve the binding now. We should try to evaluate the expression, and evaluating the expression should also contain the expression type. So here is an expression. So in by default, expression type is const, unless you actually set it to something. So here is an expression, boson val expression. So here is the word. And if it's a binding, oh yeah, that's cool. So essentially, so we can set the value, but how do we take the type of this thing? How do we take the type of this thing? All right, so I'm gonna actually return the type via that stuff. Do I really care about it? Yeah, I do actually. Oh boy, oh boy, oh boy. Okay, so here's the expression type. So this is the type. All right. Hello, programmer. Type binding binding type. So here's the binding type. And for these things, we always have to set the type to be const, right? So it's also always going to be the const. It's not going to be anything else. I love Java. Java is okay language, I suppose. Could have been worse. As I always say, Java is one of those languages that could have been worse. So. So, and in here, in all of the cases, the type is going to be expression type const. Right, and we'll have to duplicate that everywhere. All right, so bosom eval expression. So let's take some sort of a value. So we have deferred operands, allocation, unknown binding, and whatnot. And yeah, so this is going to be one of the locations. So let's actually put it here. So file location. HTML and CSS are just UI languages. You still have to program to have dynamic things. Probably. Depends on the definition of dynamic and program. Apparently different people understand them differently. Okay. So here's, I have a bosom context, then I'm trying to evaluate this expression. I do have a location. And the type, okay, so here's the expression type that I want to extract. So it's going to be just a type. CSS has animation, which may not contradict to quantum statement. As I said, depends on the definition of programming and stuff like that. So yeah, you guys like to argue about definitions, aren't you? Don't you? So yeah, now we're bringing up the Turing completeness of HTML5 and CSS, and the full cycle yet again begin. Yeah, it's like the conversation. I hate this conversation like hundreds of times throughout my life. Holy shit! It's just like it's like a Groundhog Day or something. It's just keep repeating the same conversation over and over again. Yeah. CSS, HTML, Turing complete, yeah, programming, good. Holy shit. Anyways, so, what do we have? HTML versus CSS. It's a good question. So, this is the questions I want to be asked all the time. So, who cares about C++ versus Rust? HTML versus CSS, how about that? That's a good question. Finally. It's like a C versus preprocessor. What's better? Anyways. So here's the binding, then nah. So then the type, and this thing potentially should return a value, and then we assign it to operand. Punch cut was that's a good question. Yeah. Thank you for asking all these questions. All right. So so here's the type. If it's an instruction call. Oh boy, where is my soy? Okay, so here's the type. I extract the type, and instead of binding kind, I want to do, I guess, expression. Yeah, expression. How did I call it? I just call it the type. And we don't need to do that thing anymore. Technically, should be it. Technically. Oh shit! This also means that in the future, for the entry point, you also can have an expression. Okay, so I think I'm already streaming for 4 hours and I'm a little bit tired, so I'm starting to make like mistakes. So I think I'm gonna call it a day, boys and girls. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all tomorrow. According to the schedule, we're gonna be programming in Haskell. So for all of you Haskell fans out there, feel free to join tomorrow. We're gonna be programming in Haskell. It's gonna be amazing. Check out our schedule page for more information on different projects we're working on, and check out our VODs channel where we upload the recordings of our streams. And you know what? This stream is gonna be there, but it's gonna be tomorrow on the next day. So yeah, it's gonna be later. And also check out our Discord server for offline discussion with our beautiful community. And yeah, that's it for today, boys and girls. That's it for today. Love you all.